Oh, you could leave that up there if you want. I just have this page. All right. Good morning, everyone. Thank you for joining us bright and early at 9 a.m. And welcome to the first ever Building the Open Metaverse SIGGRAPH course. I'm Patrick Cozzi from Cesium. And 1 year ago, Marc Petit from Epic Games and I organized a SIGGRAPH BOF that was the precursor to today. And we seeked out speakers who were technologists, programmers, creators, real deal leaders, and those who had a vision for the metaverse. And what we consistently heard from everyone were themes of building the metaverse in a way that is open, interoperable, and collaborative. We ended up with lots to talk about and not enough time. So we started a podcast of the same name, Building the Open Metaverse, and 31 episodes, and 1 year later, here we are, back at SIGGRAPH in person, with a full-day course this morning and an afternoon session in the same room. This is a unique SIGGRAPH course in that the metaverse is not fully built, nor is it fully defined. So this course is a combination of education on where we are and direction and inspiration on where we think we need to go together. And Marc and I don't know it all. Marc is the well-spoken, experienced, responsible adult, and, well, I'm the geek. So we've asked 9 amazing technologists and visionaries whom we admire to join us today in the same style that Natalya teaches the Advances in Real-Time Rendering course. Each speaker will share their perspectives, and we'll look for themes throughout. Before I hand it over to Marc, I wanted to share 2 notes. First, the material in today's course is about as late-breaking as it comes. I'm pretty sure there's a few speakers still tweaking their slides right now. As the slides become available, we'll post them on the course webpage here. Here's the link and the QR code, cesium.com/SIGGRAPH 2022 Metaverse. And also, most of today's speakers will be at the Kronos reception after the course today. Come by and talk Open Metaverse with us. It's just a short walk, and it's free. But you have to register with this QR code, and the link is khr.io/SIGGRAPH 2022 Metaverse. Now over to Marc.
Thanks, Patrick. First, I think we need to come clean. The rumor is true. We just met yesterday. In real life, we are a pandemic duo. So thank you, everybody, for being here with us today. And I have the pleasure to kick off this course with illustrious people. So first of all, I felt we need to start by a definition of the metaverse. And I found that Matthew Ball, in his recent book, has done a perfect job of defining the metaverse, as you can read there, to massively scale and interoperable network of real-time rendered 3D worlds that can be experienced synchronously and persistently by an effectively unlimited number of users with an individual sense of presence and with continuity of data, identity, history, entitlements, object communication, and payments. It's a mouthful, but I think it's very interesting that at least we frame the conversation by a definition. But the thing is, all of us are expecting the metaverse to be open, fair, and safe for ourselves and our children, of course. And clearly, the metaverse, as per this description, does not exist yet. But the work of the computer graphics pioneers and industry members, your work, over the past 50 years sets a foundation on which a network of 3D virtual worlds can and will be built. It will happen. We will make it happen. In 1969, when John Mates named the special interest group in graphics SIGGRAPH, he made sure to call out interactive techniques as well, back in '69. So real-time 3D is the core enabling technology of virtual worlds, and therefore of the metaverse. So we, the SIGGRAPH people, have a very important role to play in building up and shaping up the metaverse. For the metaverse to be as successful and as ubiquitous as the internet itself, it needs to reach scale and utility. It needs to become accessible to everyone and provide value to users. Achieving both scale and utility will require the acceleration of the commoditization of real-time 3D creation and playback. Real-time 3D is naturally at the core of games and simulation, but aided by the progress of AI, real-time 3D has also recently transformed the techniques and methodologies to create linear content and stories of the highest quality. So the extension of existing standards and/or the creation of new standards for the authoring and transmission of fully simulated worlds is needed to accelerate the adoption of real-time 3D and its commoditization. One of the core values attributed to the metaverse is the ability for users to wrestle away ownership of their data, and particularly of their digital goods from closed platforms. Interoperability and open standards will be required to achieve this, independently of the economic or transaction models that will prevail. So during this course, presenter will share a multiplicity of point of view and perspective on what the industry needs to do, should be doing, to set the basis so that anybody can create and share environments, objects, characters, stories, and interactive connected experiences. In interoperability and open standards will require a lot of discussion and coordination across many industry players and standards-defining organizations. That's why we created the Metaverse Standards Forum, to host this conversation. So our ambition for this course is to contribute to the conversation and allow you, the attendees, to form opinions, identify opportunities and initiatives necessary to lay the foundation of the open metaverse. I will leave you with a quote from Neal, the president of the Kronos Group, who will close this class this afternoon. When we were pitching the Metaverse Standards Forum to folks in the industry, and they were telling us, isn't it a bit early? They meant foolish, really, to try to standardize something that does not exist? And to which Neal, in his legendary calm, would answer, we do plan on building cathedrals, but what we need to do now is to agree on how we bake the bricks. And I think that's what we should be doing together, learn how to bake the bricks together. So that's our goal for today. And to kick off this class, Patrick and I thought it would be great to hear from the guy who dreamt and named the metaverse. He's an amazing and prolific author. He wrote Snow Crash, of course, but also many other amazing books. He's also a hands-on technologist who worked at Blue Origin and Magic Leap. And today, Neal Stephenson is here and will talk about the metaverse, then, now, and next. So please join me for a warm welcome to Neal Stephenson.
Thank you. This is the cover of a new edition of the book that's coming out in November to commemorate the 30th anniversary. So I'm going to start with a few minutes trip down memory lane. Part one, then. 32 years ago, I attended SIGGRAPH in Dallas. For a couple of years, I'd been working with an artist named Tony Sheeter on a graphic novel entitled Dioxin Posse. We had got interested in the potential of computer graphics as a way to generate the artwork. I gave him my old Mac SE and bought a Mac II, the first color Mac. Even then, it was possible to make color scans of photographs and get them into the computer. I had an idea that photos could be digitally processed to make them look more like comic book images. Usually in comic book art, there's an outline surrounding an object which is filled in with a solid color. I figured I could use edge detection algorithms to establish the outlines. Filling them in with solid color was a more challenging project, but I had a notion that if I converted the pixels from RGB to HSV, jacked up the saturation, and then converted back to RGB, I might end up with something that looked sort of comic booky. So I wrote a program in C that did that. And when I ran the program against the 480 by 640 pixels that pixel images that completely filled the screen of my Mac 2. It took hours. So I needed more computer power. By this time, I had moved to Alexandria, Virginia. I became aware that there was a connection machine at the University of Maryland in College Park. I acquired the manuals for the connection machine, a big pile of 3-ring binders, and studied them for a while, but realized that it wasn't going to work because in those days, the highest bandwidth way for me to get my data to the connection machine would be to throw my computer in the back of a car and drive around the Beltway for an hour. I'd become aware of the existence of transputer boards that could be inserted into the expansion slots of a Mac 2. These were CPUs designed for parallel processing. They ran a special language called Occam, so I bought one and learned Occam. So at this point, the front end was all written in C++ using the Macintosh Programmer's Workshop and generally hewing to the Apple user interface guidelines. But once you had decided how you wanted to process a given image, you could hit a button and send the job to the transputers. All of this predated Snow Crash, but there was one character from the Dioxin Posse story who later found her way into the pages of that novel. She was a skateboarder, and it was of the essence that her skateboard be capable of managing irregular surfaces. I had the idea that this would be possible if the wheels consisted of telescoping spokes. I tried to model these with a 3D package that turned out to be bad, but somehow I had become aware of RenderMan. A version was available for the Mac. I got Steve Upstill's The RenderMan Companion, and it became obvious that I could produce a model of the skateboard's wheels much more easily just by writing some C code that would generate the necessary primitives using the RenderMan libraries. So some of that imagery made its way into the project, and as a side effect, I learned a few basic things about shaders and so on. My original idea for making photographs look like comic book art never actually worked, but once I got all of this stuff up and running, I found that there were a lot of other ways that I could manipulate images to produce cool-looking effects. Tony and I used those to produce a few sample pages of our proposed graphic novel. He would print them out on a color dot matrix printer and paste them up on poster boards at large format, then reduce the images photographically. We took the resulting layouts to New York and pitched them to publishers, but were unable to sell the idea. It did occur to me that if this system could generate one image, it could generate more, and if you string those together, you have a movie. So I bought a professional-grade 3/4-inch video tape recorder, a frame grabber, and a rack-mounted box that could control the VTR in response to commands issued by my software. Since I only had one VTR, I had to use the same tape for input and output. I'd rewind the tape to a particular frame number, grab the frame, process it, advance to a blank place on the tape, and output the new frame there. By running this process for days or weeks at a time, I could produce digitally reprocessed video. Tony named the machine Jethro because the clunking sounds made by the VTR as it shifted back and forth reminded him of a hillbilly sitting in a dark room pumping a shotgun. As a side effect of all this, I had come to the attention of the company that manufactured transputers. They were going to be showcasing their products in a booth at SIGGRAPH in Dallas in the summer of 1990, and they wanted to have a few people there who were actually using transputers to solve problems. They invited me to come, and I did. My project made not a ripple at SIGGRAPH. As luck would have it, our booth was directly across a narrow aisle from that of the New Tech Video Toaster, a product that was being repped by a famously charismatic spokesperson. So I spent the whole duration of the show looking at the backs of the heads of attendees who were flocking to the New Tech booth. Since I was obligated to staff the booth, I didn't attend many presentations, so I missed one whose description I'm going to read now from the official proceedings. Special session, hip, hype, and hope, the three faces of virtual worlds. Chair, Bob Jacobson, University of Washington. Panelists, John Perry Barlow, author and songwriter. Nolan Bushnell, Esther Dyson, Tom Furness, Human Interface Technology Lab. Timothy Leary, Warren Robinette, University of North Carolina. Randall Walser, Autodesk. By now, almost everyone in computer graphics has read, seen, or experienced virtual worlds, artificial realities generated by computers which surround the user. Virtual world systems are the focus of the media, grist for the TV mill, and everyone's pick as the big idea of the 1990s. But what does it all mean? Is virtual worlds technology really that important? Panelists address the artificial reality controversy and suggest the future of professional and personal computer use. Even though I missed that session, which must have been fascinating, I don't think it made any effective difference as far as the metaverse was concerned. Although I was working alone, pre-internet, and mostly isolated from the kinds of people who show up at SIGGRAPH, I had learned enough about RenderMan to get the idea. You could use code to generate renderings of three-dimensional scenes whose underlying description was written in an abstract formalism. On the hardware side, developments such as the connection machine and transputers suggested that the rendering of such scenes would continue to get faster. With Jethro, I had already made the jump from individual still images to moving pictures. Even the Apple user interface guidelines played a role in that they laid down a framework for building apps that could be quite diverse while sharing a common set of UI primitives. All of this hinted at a future still pretty far away in 1990, but easy to imagine, in which immersive three-dimensional environments became a new communications medium. Having set fire to a big pile of money acquiring the hardware for this project, I became fascinated by the question of how the price of hardware might be brought down to a level where it was within reach of typical households. Something similar had happened during the 1950s with television. A feedback loop somehow got started whereby the popularity of certain programs caused more people to buy televisions, which drove their price down while giving manufacturers incentives to invest in larger screens and higher quality. The metaverse was my conjecture as to what might do for 3D computer graphics what I Love Lucy had done for television. So I wrote the book. As it happened, what actually brought the cost of graphics hardware down was video games, in particular Doom, which came out the year after Snow Crash was published. That and the many games inspired by it caused the video game industry to grow to the point where its revenues have long since eclipsed those of Hollywood. The World Wide Web came into existence at the same time and led to the explosive growth of the internet. It also sold a lot of computers and graphics cards to users who wanted to be able to see pictures and videos on their screens. Those two factors made computer graphics cheap and ubiquitous without the need for a single metaverse as described in the novel. At the risk of seeming entirely self-centered, I'll mention that some of my subsequent books also talked about immersive experiences and how the underlying plumbing might work. The success of Snow Crash, at least among the geek population, brought me into contact during the mid-1990s with privacy and crypto enthusiasts, loosely calling themselves cypherpunks. During my occasional encounters with them, I would hear about their ideas for anonymized, decentralized communication on the internet. That influenced the storyline of my next book, The Diamond Age, the plot of which makes no sense unless you assume the existence of fully anonymized, encrypted, decentralized communication and payment systems. The next book after that, Cryptonomicon, is explicitly about cryptocurrency. The series of books after that, The Baroque Cycle, is in part an extended riff about the origins of the modern monetary system. Skipping ahead to ReamD in 2011, that's a whole book about a fictitious video game, T-Rain, that's based on financial plumbing that uses real money. Part 2, now. So fast forward 32 years. In order to achieve what I was thinking about in 1990, namely to get millions or billions of people using the metaverse, we need to create experiences that people enjoy having. There are people who are good at that. By and large, they are employed in the game industry, or increasingly film and television, which are making use of game engines, a trend that was heavily accelerated by COVID and the restrictions it placed on the movement of talent around the world. The basic problem to be solved in all creative industries is how to get artists to make art in a coherent, coordinated way. And by artists, I'm including people who work in various roles in the game and web dev industries, not just the obviously artistic jobs such as texture artist or animator, but game designers, programmers, and so on. Sadly, from the point of view of investors and executives, this involves paying them money. The only consolation for this tragic fly in the ointment is that there might one day be a return on that investment. With occasional heartening exceptions, investors try to pay the artists as little as possible while steering their creative output in the directions that involve the least financial risk, which is how we end up with an endless stream of nearly indistinguishable superhero movies, free-to-play mobile games, etc. From the standpoint of the artist, this boils down to getting someone to write them a check, and it is an eternal source of wonderment how well-heeled companies and financiers who never stop proclaiming their adoration for the creative process and their excitement about specific projects suddenly disappear when it comes time to pony up the dough. Anyone who reflects on this for very long will find themselves wondering what is the point, after all, of the whole apparatus of studios and publishers. Traditionally, these entities are banks that, at least in theory, can finance creative productions. But that just means a reservoir of money. The reservoir has to get filled from some source. Ultimately, that source is the individual viewers, readers, gamers, etc., who are en masse making small individual payments in exchange for experiences that they like. The executives who control the reservoir then decide where to place their bets on the next round of creative production. Pre-internet and pre-game industry, creative industries did actually need an intermediating layer of executive decision-making and bet placing. Those executives were acting as professional stand-ins for the tastes and preferences of mass audiences whose only way of sending data back up the chain was to buy a ticket for a movie or not. Wouldn't it be great if we could replace those executives with data pipes, since that's all they really are? In the early days of the internet, many of us believed that this would happen and that artists would get paid directly by fans. This didn't work out, at least in the case of music. First there was bootlegging, then streaming services. While it is true that musicians can get payments from streaming services, those payments tend to be very small. Between that and the COVID shutdown, it has been a bad few decades for musicians. For them, the internet looks like a shitty deal, a massive transfer of money away from artists. How can we prevent history from repeating itself in the case of artists who contribute their work to the metaverse? There is an answer from the crypto world, NFTs, which can make use of blockchains to publicly assert that a particular artist created a particular collection of bits no later than a particular time. Connected with those, we have smart contracts, which can, in theory, channel payments to those artists. There are some caveats, at least in NFTs, as they first came to prominence circa 2021, and I'll get into that topic later. First, though, rather than talking about this from a defensive crouch, I'd like to focus on the desired vision. And for that, I'm going to quote from Jaron Lanier, who is trying to solve the problem of crypto that doesn't build, as opposed to crypto that merely concentrates. In essence, he's drawing a contrast between pure speculation, a common accusation leveled against crypto, versus actual creation of economic value. How do you structurally incentivize creation as opposed to speculation? When the creative works sold as NFTs are disembodied collectibles, the economy arising from their sale and resale can seem like mere speculation. Opinions may differ on whether that is okay. People have traded in collectibles such as comic books, coins, and stamps since long before the internet. Again, I tend to come down in favor of anything that leads to artists getting paid, and a lot of artists are making money from NFTs. But it's neither here nor there as far as the metaverse is concerned, because metaverse experiences can't be assembled from disembodied collectibles. They have to be engineered. Part of that is, to be sure, the creation of assets in the game industry sense of that term, 3D meshes, sound files, particle systems, and so on. But merely dragging assets into a folder doesn't create an experience any more than stacking a bunch of lumber, wire, and appliances on an empty lot makes a house. Thus, we find our way into the interconnected topics of blockchain in games, NFTs, and interoperability/composability, which has been controversial of late. Let me just say the following. NFTs are purely digital objects. Under the right conditions, however, purely digital objects actually can be assembled into things of legitimate creative and economic value. They're called games. A framework that allowed digital objects on the chain to interoperate as in a game would be an engine of genuine creative and economic value, and as such should be safe from the accusation of being mere speculation. Interoperability, along with the use of cryptocurrency and NFTs, has become a flashpoint on social media during the last year. A lot of people feel compelled to take stances on it because that is how your brain harvests dopamine from the internet. Post a take on something and wait for the likes to roll in. I'm more of a wait and see kind of guy. As Marcus Aurelius said, it is in our power to have no opinion about a thing and not to be disturbed in our soul, for things themselves have no natural power to form our judgments. Some of these negative takes are rooted in blanket objections to crypto, which I don't have time to address here. This is a computer graphics, not a crypto conference. Setting that aside for now, many game devs have expressed hostility toward interoperability proposals on two main grounds, technical and aesthetic. The most succinct statement I've heard relating to the aesthetic objection comes from Marc, founder and CEO of Shrapnel, who put it this way: we're not saying that you should be able to bring your sniper rifle into a soccer game. Many games are coherent works of art that take place in fully realized fictional worlds. It's the life work of the people who make such games to see to it that every detail of the art direction, music, sound, and gameplay are consistent with a unifying creative vision. When advocates of interoperability, typically crypto bros with a certain ideological axe to grind, show up in their feeds demanding to be able to bring extraneous game objects into their worlds, it feels disrespectful. It feels that way because it is. There is, however, a huge and thriving market for games that are creative mashups. Three of the best known are Roblox, Minecraft, and Fortnite. Fortnite has continued to engage users by pulling in IP from a wide range of pop culture sources. There's nothing unusual there about seeing a four-person team consisting of Iron Man, John Wick, the Silver Surfer, and a blue banana. No one is the least bit troubled by this. It's part of the fun. What's interesting about that overall look and feel is that it is essentially Metaverse-like. The Metaverse, as described in Snow Crash, is just such a creative mashup. The answer, then, to the aesthetic objection goes something like this. The Metaverse is big. It contains multitudes. There are going to be public spaces that are mashups, but there will also be specific zones where different rules apply. You could think of these as being analogous to a Renaissance fair. When you go and visit a Ren fair, you're agreeing to buy into a particular aesthetic that only applies within the boundaries of that event. You're willing to do that because you enjoy pretending to live in a medieval village for a couple of hours. It's interesting to think about how the equivalents of Ren fairs might be established in the Metaverse and how the art directors and game designers of certain spaces might be empowered to assert editorial control over the avatars and game objects that are capable of being manifested in those spaces. When you step over the boundary of a Metaverse property into a medieval world, the lightsaber and blaster might disappear from your inventory or be grayed out or even be replaced by objects of somehow equivalent value that are germane to that world. Ideally, this creative control ought to work in both directions. As I've just pointed out, the proprietor of an experience might want to ban certain objects from being brought in, but the creator of an object might prefer that their work not be used in certain kinds of environments. For example, if I've created an avatar that's childlike in appearance, I might be perfectly happy to see it used in kid-friendly environments. But if it showed up in certain other kinds of environments, it would suggest that something creepy was going on. This sounds hard to implement in an open system, and maybe it is, but it's being worked on, and I'll circle back to it later. The basic technical objection to interoperability I've already mentioned. You can't just drag and drop assets from one game to another. People who think that don't know anything about games. There are a number of ways to attack that technical problem. I don't pretend to be aware of all of them. This is an active enough field that I don't think it's possible simultaneously to stay on top of everything that's being done and to actually do anything. In the next and final part of the talk, though, I'm going to mention some conversations I've been having with people who are working in related areas. By way of full disclosure, I'm doing this in my capacity as a co-founder of Lamina One, which is a startup dedicated to launching a Layer 1 blockchain aimed at exactly these sorts of applications. I'll make other disclosures as I go. Part 3, next. B copy. Disclosure, I'm about to become a customer of Bcopy. It's spelled B-K-O-P-Y. The NFTs that hit the market during the boom of 2021 look to have been hot-wired together from then available constructs in the blockchain and cryptocurrency world. It's a first-generation product that needs to become a lot more fully baked. This is being worked on by Josh Kramer in the Seattle area. He's the former head of motion picture business operations at Amazon Studios, and as such had a kind of Olympian perspective on matters having to do with IP agreements, but he has also known how to code from a young age. Josh has actually done the hard work of reading through the fine print, such as it is on existing NFT marketplace agreements, trying to pin down exactly what, if any, rights are being transferred to the buyers. And it's a mess. Sellers aren't making representations that they actually own the artwork being transferred. In the case of allegedly limited edition runs, they aren't making any legal commitment not to just crank out more of them. Buyers aren't really coming away with clearly defined rights as to what they've bought and how they're allowed to use it. And exactly what they're buying isn't really clear anyway, because putting actual assets on the chain is at the moment economically prohibitive. Consequently, the on-chain components of traditional NFTs, the data that can actually be verified by inspecting the online ledgers, are mostly pointers to files stored off-chain, typically an IPFS, interplanetary file system. The drawback, as many have pointed out, is that the files pointed to can be altered or even disappear altogether. If that happens and the thing you bought and paid for is only defined as a certain pointer into IPFS, do you still own anything? What is it? Do you have any rights? To make an analogy to real-world property transactions, if someone is trespassing on your land and you call the sheriff and ask for them to be arrested, the sheriff's ultimate source of authority for doing so resides in a legal document, a deed that gives you ownership of that land. If you were to buy a piece of property using a blockchain transaction, as those are currently structured, you would definitely be spending the money, but you wouldn't actually get legal ownership of anything because the law would not recognize a smart contract as a source of truth for real estate ownership. Until that changes, how can blockchain transactions that are concerned with non-blockchain assets be legally enforced? That's the problem that Bcopy is addressing. It's a technology for binding a token to an enforceable legal agreement. In this system, a legal contract, a legit binding agreement, is posted in its entirety on the chain once. The cost of publishing one page of text to the Ethereum blockchain can be as high as $500, depending on the gas price and the Ethereum price at publish time. So easily thousands of dollars for a document long enough to contain an enforceable legal agreement. But in the Bcopy scheme, that only needs to be posted once. Subsequent transactions are recorded on the chain as much smaller NFTs that simply refer back to that original agreement. Buyers, therefore, know exactly what they're buying. Both buyers and sellers are making legally binding representations spelled out in the agreement. The seller, for example, might state that they're only selling so many copies of a given NFT and that this number will never go up. Sounds obvious, but it's absent from many existing transactions. The buyer might represent that if they resell the artwork to someone else, they'll pass a percentage back to the original seller. That's also a common feature built into many NFT smart contracts, but not in a legally binding way. Is this relevant to the metaverse or only to the NFT market? Well, you might remember earlier I was talking about why it might be important for an artist, the creator of a game object, to be able to exercise some control over where it was used. There are a lot of ways in which that could be important. If I'm a visual artist and I sell something, my expectation is that the buyer might display the artwork in their home, real or virtual, or hang it on the wall of an office, or in some other way display it privately in a location associated with them. But if they turned around and used it as the logo for a new product, then I'd expect to be compensated for that. And if I disapproved of the product for some reason and didn't want to be associated with it, I'd like to have veto power over that usage. So when Bcopy inserts binding legal agreements into NFT transactions, it's about more than just the art market. They're actually pioneering new features that are going to be foundational to building an open metaverse. Shrapnel. Disclosure. I'm an advisor to this project and I'm being compensated with tokens. Shrapnel is a game under development by Neon Machine in Seattle. This game is going to be integrated with NFTs, blockchain, and so on. Under the hood of this project, there's a lot of thinking and engineering going on that's relevant to the use of blockchain technology, not just in this one game, but in the metaverse at large. Let us imagine a hypothetical case in which someone has written a book featuring a magic sword and wishes to see that sword in the metaverse. The first step might be to mint an NFT that somehow embodied the unique characteristics of that sword. At a minimum, that would be some metadata, its name, what sort of thing it is, its dimensions, quotations from the book, etc., and a picture providing a general template for what it looks like. Call this the stub asset. This would be sufficient for the artist to put a stake in the ground saying, here is this thing I created, and to assert some rights. But in and of itself, it would still be a far cry from a working asset integrated into a game. As such, it wouldn't be capable of generating economic value, since fun experiences are what gamers actually pay for. Games are built on engines. The two most common ones are Unity and Unreal. They use different languages, coordinate systems, units of measurement, and so on. Beginning with the stub asset, it would be possible for someone proficient with a game engine to produce a generic version of the magic sword that would work in a typical game built on that particular engine. In other words, a Unity asset or an Unreal asset. There's also GITF and other standards, but creating a GITF version also requires some effort and some know-how. There are already thriving marketplaces for game assets that can be bought, sold, and used in exactly this way. One can start to envision this as a tree structure where the root asset, the original stub NFT posted on the chain by the artist, now supports multiple branches, one for Unity, one for Unreal, perhaps a GITF. Obviously, more could be added for different engines and standards. An asset purchased on a store and dropped into a game is still a long way from being satisfactorily integrated into said game. Additional work needs to be performed in order to wire it into the game's programming. This will be different for each game. Moreover, each game has its own art direction. The artwork provided in the inherited asset might clash with the overall look of a given game. Developers would have to redo the art in order to make it look right. So the tree has to grow. Additional branches are needed, one for each specific environment in which the magic sword is capable of appearing. In the process, it's possible that a developer might alter the magic sword's appearance to the point where the original creator wouldn't recognize it anymore and wouldn't be willing to bless it as a legitimate embodiment of their idea. Trolls might even produce versions that are patently offensive. Some kind of approval process, therefore, needs to exist so that the original artist can sign off on the new artwork. This is clearly related to what I was talking about a minute ago in the case of B-Copy, and indeed, the developers at Shrapnel are admirers of Josh Kramer and the work he's doing on this front. Performing all of this integration clearly involves contributions from artists, programmers, sound designers, animators, etc. If the result turns out to be worth anything, if players play the game and like it, then those people should get paid. The whole scheme goes nowhere if the game makers have no economic incentive to do the work needed to integrate these assets. Since early in 2022, Shrapnel have been working on a smart contract format called Sigma that's intended to do what I've just been describing. This was the case as far back as February, which is when I first heard about this. More recently, the blockchain engineering team at Shrapnel, including Marcus Jones, who is here in the front row if you want to talk to him, have been looking at ways to further decentralize the way that these things are implemented. The traditional NFT scheme consists of some decentralized elements that are embedded in and dependent on conventional centralized technologies. For example, the thing that keeps track of the user's identity is a wallet extension that's embedded in a conventional web browser. When the user wants to change the state of an NFT, for example, transferring ownership to someone else, this extension sends a message to the smart contract, which has some limited ability to execute code. The output of that code goes to a web server, which might typically be running on an AWS instance. This is traditional centralized web technology. The website serves an event back to the user's browser via JavaScript, but a more fully baked version of the process would get rid of the web browser on the user's end and the web server on the other end. The user's wallet application, the thing that knows who the user is, communicates directly with an upgraded version of the smart contract that can execute code inside of the validator node. Results are transmitted directly back to the user's wallet, eliminating the apparatus of web servers and browser. This requires some upgrades to the wallet, but it eliminates all of the traditional centralized web apparatus and seems like it would be a better fit for Metaverse-style applications. Agoric, no disclosures here. Earlier in this talk, I mentioned that after Snow Crash was published, I came into contact with people in the tech world who had been thinking about related topics. Several of them had worked on Habitat, an online community from the late 1980s that anticipated many of the features we now associate with the metaverse. They even used the word avatar in the same sense as it was later used in Snow Crash. One of the key things that they figured out very early is that a decentralized metaverse-type system is inevitably going to require that you, the user, end up executing other people's code on your hardware. That seems obvious now, but it wasn't then. It's certainly obvious to people who know game engines because game objects can't perform their basic functions without executing code. A typical game object, for example, might include procedural shaders, which are arbitrarily complicated computer programs in their own right. So even in the early 1990s, these guys were thinking about how to make use of crypto to set up computing environments in which arbitrary code from non-trusted sources could be allowed to run on a system without compromising that system. The people I was talking to were Randy Farmer, Chip Morningstar, Doug Crockford, Dean Tribble, Marc Miller, and Doug Barnes, though this is by no means an exhaustive list of everyone who worked on this stuff. At the time, they were developing a language called E, which was intended to solve this problem. Later, Doug Crockford became a leading developer and proponent of JavaScript, which, as you may know, is a foundational element of today's web. Obviously, JavaScript as a client-side language needs to address many of the same basic security issues as E. Currently, Marc Miller, Dean Tribble, and Chip Morningstar are all working at Agoric, which describes itself as an open-source development company launching an interoperable proof-of-stake chain and economy. It has been acquired by Microsoft, but as far as I can tell, runs as an independent company. For an interesting readable overview of what they are doing, I recommend a July 8th interview that Dean Takahashi did with Chip in VentureBeat. A key feature of their platform is the ability to program smart contracts in hardened JavaScript. 13 million plus developers know how to use JavaScript, so this would open the door to a much larger community of devs. Quoting directly from Dean Tribble here, the platform has a modern object-oriented framework for rapid composition of applications from the components that other people build. And quoting from Marc Miller, for an open metaverse, the important part of the Agoric stack is that it runs across mutually suspicious platforms which can serve as separate hosts for different parts of the virtual reality. Finally, quoting from Chip, they are about enabling people in far-flung parts of the world or in communities that wouldn't otherwise interact with each other to be able to cooperate in constructive and beneficial ways. If you lower the risk of cooperation, you get a more cooperative world. By way of wrapping this up, let us return to the example of the magic sword mentioned earlier. Let's say that Alice is carrying the sword around in the metaverse, but decides to transfer it to Bob. At the end of the transaction, it needs to be the case that Bob possesses the sword and Alice doesn't. This needs to be the case even when Alice and Bob move to other regions of the metaverse that are managed by other companies. The transfer of ownership therefore needs to be recorded somewhere on a ledger that's universally accessible and trusted. Moreover, if this transfer was a sale, then money needs to change hands. If this is happening according to the Sigma or similar contract described above, some percentage of the sale price ought to be passed up, what Jaron Lanier refers to as the value chain, to the artists who originated the IP and made it all possible. These transactions, recording events on trusted, world-readable ledgers and transferring money between wallets, map directly onto functionality that blockchains and cryptocurrency exist to provide. Strong arguments can be made, and frequently are, that the same functions can be carried out by non-crypto means, What those arguments boil down to for our purposes is whether the perceived shortcomings of current chains are inherent to all possible crypto schemes, or whether a new one, custom engineered for metaverse applications, can get the job done. For what it's worth, I am betting on the latter, and I hope that in some future SIGGRAPH I can report on what Lamina 1 will have achieved by that point. I tend to agree with Chip Morningstar, who says in that July 8th VentureBeat article, speaking about what they're doing at Agoric, the end is being able to have reliable, trustworthy computation that doesn't require you to have an intermediary who's a trusted third party. Rather, you get the effect of having a trusted third party by an emergent process from the blockchain. We're using blockchain as our trusted computational engine for doing contracts. The growing metaverse is a competitive environment in which blockchain and non-blockchain solutions are going to coexist for a while, just as they do and will continue to do in the economy at large. It's my view that the solutions that thrive are going to be ones that solve practical problems for the creative and engineering talent who constitute the real scarce resource in this economy. Thanks for your attention, and I'll let these guys handle the timing of everything, but I think there's time available for questions.
Yes, absolutely. Thank you.
Yeah.
Thank you, Neal. We do have a few minutes for questions. There is a microphone in the alley if you guys want to grab it and ask a question.
Might be worth mentioning that Marc told me when we were getting ready for this that I would be the one kind of Web3-ish blockchain-y speaker. And so that's been the main emphasis of my talk today. In case you all are wondering, this isn't going to be an all-day seminar on blockchain and crypto, unless you want it to be.
Unless you want it.
Yeah.
Are you guys ready to edit your slides and add some NFTs? All right, anybody up for a question for Neal?
Someone, yeah. Back there.
Please go ahead.
Oh, Shell?
The environmental impact of the blockchain and
And repeat the question.
Yeah, so
Repeat the question.
the environmental impact of blockchain and metaverse. So the original blockchain, Bitcoin, is famously wasteful of energy and is quite bad. Excuse me, when it comes to carbon footprint, and that's an inherent feature of the way it works. It's based on a proof of work scheme that basically can't be implemented without spending a lot of energy. More up-to-date blockchain systems are using proof of stake, which, to make a long story short, can be orders of magnitude more energy efficient. So to the point where it's kind of down in the noise. It's kind of at the same order of magnitude as things you probably do every day. However, any carbon footprint is too much, and so part of what we're doing in the new venture is to build in carbon negativity to the chain. So to the extent that the nodes for Lamina 1 are going to be consuming electricity and possibly putting CO2 into the air, they need to demonstrate that they've purchased legitimate carbon offsets. And what constitutes a legit carbon offset is a vast field of debate and confusion unto itself. But there are people who are in the business of evaluating these things and trying to separate out the good ones from the less good ones.
Yeah, if you want.
Oh, thanks. Thank you.
Emmanuel?
I think in SIGGRAPH, one of the very interesting things in the where Metaverse was a protocol. So there were things which have to be agreed in public places, and there were things which could run differently into private places as soon you kind of pass a private property. Also, in some of your books, you're having this discussion about, like, should we build a metaverse which look like reality? And there is all this talk right now on the metaverse where we kind of in a realistic model, it's always a planet, it's always 3D. But so we can imagine a lot of other universes which don't fit to the same rules. So I know it's a big drop on the thing, but you didn't talk at all about this.
About whether the metaverse can or should be realistic in the way it looks. Yeah, I'm not a believer in any kind of top-down prescriptive approach to what the metaverse should look like. It's got to be a bottom-up. Individual builders need to decide what they want and build it. And so I do think that to make a coherent metaverse, there are certain really basic things that have to be consistent, such as the size, the scale of avatars. But I think it's best to keep those kinds of rules to an absolute bare minimum and then let people do whatever they want to. I think that what we'll find, my prediction is that most people want something that's fairly realistic, because it can just become too confusing and bewildering if it's a completely chaotic, kind of random environment. And when it comes to social interaction, people want to look a certain way and interact with each other in a certain way. But I don't think that should be a top-down rule. It should be something that's established by people building their own ideas from the bottom up.
Next question,
There's
please.
There's
we
a
have few
queue
people.
at the...
Thank you. Good morning. There seems to be some opposition to smart contracts, and they are being compared to pyramid or Ponzi schemes. Have you ever faced this type of reaction when talking about the economics of NFTs? And what are your thoughts on the matter? Thank you.
Well, I don't think that the smart contracts per se are can be linked to Ponzi schemes. I think that, as I was saying in the talk, there have obviously been a number of cases in which NFTs were used in basically speculative schemes, where the only kind of the only value that they seem to have is in the expectation that somebody else is going to pay more money for it than you paid. So that's a good definition of speculation. I think the solution to that is to have objects that are of genuine creative and economic value. As I was saying, we have that in the game industry already. The reason that dollars and euros are valuable is because people use them all the time to buy potatoes, gasoline, steel, and so one can feel confident that dollars or euros are a legitimate store of value. If we have an economy in the metaverse where tokens are being used to purchase and trade in game objects, then and those game objects are considered to represent legitimate economic value, then I don't think it's a speculative scheme at that point. Thanks.
Next question, please.
Hello. I was struck listening to you talk about the past and the present and the future, reminded of the 90s and the sort of feelings we had about the internet and how it was all new at the time and it was going to be a sort of democratic upsurge of freedom of knowledge everywhere and a lot of collaboration. And I hate to bring this up, but
it's not.
It's not, and it's awful, and I hate to even say this, but I feel like social media really demonstrated that we don't know what we're doing, like with each other, like how to build this, and I feel like I want to be in this metaverse you're talking about, but I also remember that sort of feeling, and I wondered what your thoughts were on
Right,
that.
is this that again? Yeah, well, I guess I mean, the two big things that I worry about are what you just said and carbon. And carbon's an engineering problem, and there's, I feel like I can think about that constructively. The other one is a social, political problem, which is harder to engage with. I do think that the business model and the revenue model has a lot to do with this, and so that the essence of social media platforms tends to be that they're free to use, and so as the saying goes, if you're on a website and you can't figure out what the product is, the product is you. So I think that, and Jaron has been incredibly well-spoken on this topic and how the incentives of those kinds of sites tend to create a feedback loop where the sites want you to be emotionally engaged, and what's the best way to do that is to make you mad or to make you scared. So one of the things that I consider promising about the kinds of things I've been talking about here is that there's a transparent economic model in place. And so you're not, as a user, if I go, the analogy would be if I go to Steam or the Epic Store and buy a game, the economics of that are very clear. It's like, this game looks interesting, here's some money, now the game is mine, I'm going to play the game. So there's no hidden incentives or tricky stuff going on. And I would hope that if we can start anew and build a new system while being aware of everything that went wrong with Web 2, that we can address some of these issues as we go along. Yeah.
Thank you.
Thanks.
Okay, so we'll try to go through the last two questions there. So go ahead.
Just a quick one. I was wondering if you can comment on if and what role the government plays in the development of the metaverse.
I think that in a sense they play a role by funding basic research and kind of keeping institutions going, where the ideas come from. Beyond that, I'm not a reflexive, hardcore, anti-government kind of guy, but I just don't. I think that this is such a complicated and rapidly changing field that I'm worried that even well-meaning efforts by governments to help out would not work, just because they'd be obsolete by the time they made it through Congress or whatever.
Thanks.
Yeah.
And our final question.
Okay.
Hi, thank you. Thank you for your talk. I was curious because, I don't have comprehensive experience with portrayals of the metaverse in fiction, but most of the ones that I've seen take kind of a far from utopian kind of perspective of its role in our world. Oftentimes, at best, it's seen as it's portrayed as a distraction from kind of real problems in the physical world. But I'm curious, what do you see as your North Star in terms of how we should think about this metaverse as many of us are putting together the pieces today?
Yeah, so Snow Crash is obviously a dystopian novel. It's also a parody of dystopian novels. It is trying to be funny. The metaverse is depicted as being not inherently bad or good. We see a lot of the kind of schlocky, exploitative parts of the metaverse in the book, but we also go to the homes that Hero and the character Ing have built for themselves, which are beautiful works of art. So I don't think that even you know, I can grant that Snow Crash is a dystopian novel without taking a position on whether the metaverse is inherently dystopian. And I don't think it is. I just think it's a tool. I mean, Earth is in Snow Crash 2, which I'm told became an inspiration for Google Earth, but we don't think of Google Earth as being a inherently dystopian technology. So I guess that's my basic stance on that, and I would, the only thing I'd add is that distractions aren't bad. They're not inherently bad. Like when we go to a movie or read a book or play a game, or just go for a walk, you know, those could all be categorized as distractions from the problems of the real world. But we do it anyway, and it's not viewed as somehow a harmful activity. I think it can be a beneficial activity if it's not used in a kind of pathological way.
Makes sense. Thank you.
Yeah, thanks.
Well, Neal Stephenson, thank you very much. It was
Thank you.
Highly educating. Thank you. All right, so while our next presenter sets up, I'm going to introduce him to you. So Guido, go ahead. So this next presenter has contributed immensely to the CNG community. During his 24-year-long tenure at Pixar, he led the development of amazing tools that gave us amazing movies. He also initiated and contributed to many open source initiatives. He's, of course, the mastermind behind USD. He was not alone, but he was the key architect, and I think most of us in this room hope that USD will play a critical role in the metaverse. If you look him up on Wikipedia, he comes up as an Italian voice actor. And so is he more of an engineer or an artist? Let's find out. Ladies and gentlemen, Guido Quaroni.
I should have put a few pit stop then in there, but I work at Adobe. I'm responsible for the engineering team at 3D and Immersive, the team that delivers Substance Painter, Substance Designer. So when Marc reached out to me to talk about the metaverse, immediately I started thinking USD, GLTF, this and that, and then I realized that the more I was having those thoughts, I realized how much what is the definition of metaverse that I have in my mind, and even more, what is the open metaverse means. You know, I had an interaction with a few engineers that are saying, we're building the open metaverse, and I said, oh, interesting, so when I go in, can I just give just a very simple ID? Not quite. I'd like to have more information if possible. Can I use any device I want? Not all of them. Can I bring my avatar out of it? Not quite. And so I started to realize that the one thing that we may be missing is a full understanding of metaverse and the concept of open metaverse and how it relates, obviously, to technology. So I just want to go, I have some thoughts and some ideas, some reflection that I would like to share with you. First of all, like some assumption on the metaverse. I believe actually that the metaverse itself, you know, if we assume is a computer-generated virtual environment where people can interact with each other through avatars, it has to be believable. It doesn't have to be realistic, and this is related to the question before, but you want to relate to things, relate to people, and so it has some sort of believability. And also has to give you predictable experience. If there is some laws of physics into that world, after you experience a little bit, you want to start having some predictability to not go completely crazy. And there are being kind of a different way of experiencing the metaverse. There is kind of an external observer or an immersed participant. So there are two levels, and some of them are connected to the evolution of the software and hardware and how it's been improved over the years. So if you think about the observer, it's like a window into the metaverse, and it's been done in many ways, especially from desktop apps, web, tablet, where actually you have kind of limited interaction with the environment, and you have mostly a single user experience. So maybe you can do some manipulations, you can do renders, et cetera. You can see things, but not as much of an interaction, and just mostly by yourself. And then when you look at it, you're a participant instead, and you throw in like, oh, I got some new fancy devices that I put on, and I can really be immersed. You kind of have a door that you go through and that door goes into you get into the actual metaverse. And that's, you have more direct control. You have an immersive experience. And then you can interact with avatars. So, and this is where where we're moving toward, the more, again, computing speed and software improvements, et cetera. We are going to have more and more like a more direct experience with that. But let's go back to the open metaverse again, because I'm sure how many things now there have open in front. Opens all sorts of project and product. And so I just want to keep thinking about it. What does it mean really open? Open has to be accessible. It means it has to be accessible. This is, again, beliefs. I think it's important. It has to be inclusive. It has to be reproducible. That you have to be able to reproduce, in different contexts. What do you mean for accessible? And this image is kind of a more thinking about it being anywhere in the world. Obviously, you need internet connection, but you may be in places that not necessarily you have a super fast bandwidth, and so you can provide amazing 3D graphics. But actually, you need to think about it. What does it mean to be also a system that's sustainable for low bandwidth? You need to think about this because so many times we get caught into like, oh, looks amazing, look this, and you keep pushing and not realizing that you may come up with things that for so many people may not be possible to experience because they just don't have access to that speed. And the other one is the multiple surfaces. Not everybody has 64 cores, a few fancy GPU cards. For some people, they may have like a mobile phone or something a lot more simple and less powered. And so again, you want to also be thinking about something that is sustainable, also at low compute. And the other one, the last thing is multisensory. I mean, we're so focused on the imagery, but actually we should really think about what is the audio, spatial audio, and focus on that because, again, if you want to welcome everyone, not everyone can be able to appreciate just the visual of what a virtual world may provide. When you think about inclusive, and how do we have an open metaverse that is inclusive, is, well, everybody's welcome. You want to make sure that there is no boundaries to be able to access, the same way that, if in open countries and open, you go to cities and you can visit and you can go there. And then you want to have simple access, simple unique IDs. I don't consider an open metaverse we're open, but here it is, everything including your last 4 digits of Social Security, just in case. And it has to be really simple and really minimalistic to be able to access it. You don't want to pay. I mean, there's nothing wrong to have paywalls for certain metaverse, but again, an open metaverse should not ask you to any subscription or anything related to that. And also no pressure to stay or leave. That may sound like, what is that? But as you may know, there is maybe a desire and an intent to really keep people for a longer period of time, or maybe not welcoming people that are maybe not aligned with some of the beliefs of that given virtual world. And finally, reproducible, because everybody should have access, the possibility to reproduce, maybe in a much smaller scale. There may be metaverses built by big companies that can put tons of servers and advanced technology, but it would be great to be able to do something if it's open, to be able, well, somebody may want to do just a room with a few friends. So assets need to be interoperable between open metaverses, and also compatible with creator tools. So making sure really that there has to be an ecosystem, there is an ecosystem out there of commercial and open source software to create content for the metaverse. And so lots of attention needs to be put into that aspect, again, if you want to call your metaverse open. And also having as much as possible the components of this to be also available as open source. And the reason is, it doesn't mean that you have to, that everybody has to have their technology open source, but it would be awesome to have something that is standardized and there is an open source implementation so that, again, it can be accessible for individual or smaller companies that don't have the means to build something this big. Because if not, I mean, this image is like, it's the kingdom, the metaverse kingdom or something. It was generated by AI, and it kind of looks an interesting thing. It's like, the idea that we don't want kingdoms of the metaverse, and so only big players can play that game. And another important aspect is the avatars. And so this is kind of a manifestation of individual users, and they need to be customizable and in the way representation. Again, doesn't have to be fully photoreal. They want to be believable, but embody. And also you may want to have multiple of those. But more importantly, reusable across open metaverses. This is an important one because we don't want to end up, you build it in one place, maybe you buy a hat, shoes and something, and then suddenly you have to do it n times. And if this thing keeps growing and growing, at some point we may end up in a situation where you have to do it 10 times, 20 times, if you want to be able to access those environments. So what are some of the pillars? Now going back a little bit more into technology, on the technology of it. The main pillars, the way I see it is components and interaction between those components, the law of physics that govern the metaverse, and then the user experience. So let me go into those three pillars one at a time. The components and interaction is, they can be of different kind. So those are what define the world, and it can be declarative component, like something that you model, or a procedural, like leaves on a tree. So both of them need to coexist together and interact potentially with each other, but they may come again from more explicit declarative processes versus somebody's writing software. Immediate of the fur, again, not necessarily you need to serve everything, because again, you need to think about it, maybe low power devices and low bandwidth. And so think about what does it mean, immediate components or assets in a way, or deferred. And then a distinction between atomic and independent components, so elements like a surface, a single object, can be placed on its own and has no connection with other objects, or aggregate, and aggregate of aggregate. So be able to understand that, you may want to build and keep building on top of each other. And those are the components. In the interaction, two are important aspects. Relationships, be able to say, I want to constrain two objects together. So I want to define, what does it mean? I'm gluing something to something else, so then if I grab it and move it, it comes along with it. Or connection, and things like, I want to turn the switch, and the lights turns off. And so as you think about it, what it could be a standard or a way to define, and again, there is a ton more. Those are some of the thoughts I'm sure I'm not covering. You may have, you forgot this, this, and this. There's plenty. But those are some of the aspects that you really want to think about it in this context. In terms of the law of physics, how do you define it that you have forces within the metaverse? And again, they don't need to be 100% realistic, but you want to have it believable and consistent, possibly. And then also having intervention for the user, so you respond to, you grab object collide with each other, the form as they collide, etc. Again, to give you that sense of really believability of the world. And finally, delivering the experience. Has to be responsive. You want to think about always making sure that you have technology that keep you a certain rate, because the world doesn't stop ever. Again, believable, multisensory, and then consistent across surfaces. It doesn't have to look the same, but you want to make sure that he has some level of consistency, so then you feel like you can experience the same thing. What are kind of so what are ultimately the fabric, of the open metaverse? I think it's important that it's defined by open standards, and those open standards are governed equally by provider and user. I mean, metaverse providers and user. And this is a really important, that's interested to join into the various body of standards to make sure that we work together, because so many standards came actually from user, people doing the work, and then adopted by vendors. Sometimes it's really a tight collaboration. So the hope here that those components, those aspects that will build the metaverse are really, they came from a synergy between those two. Have, again, open source implementation. Again, I consider it like a pillar to have a representation, at least a reference that can be there for any given open standard. Accessible, so this means also the licenses, be able to have very permissive licenses, so then you can use it, you can change it, you can do a little bit whatever you want there. And so there are a few emerging standards that are coming up, obviously, and some of them, you'll hear about it in a minute, about some of those. But fundamentally, right now, they're sitting in two major areas that at least I'm seeing. One is on the authoring space. So it's standards that really have a rich set of schemas to represent as many class of objects as possible and behaviors as possible. They allow you to have aggregation, so you start building, from object to rooms, to houses, to cities, etc. They enable multi-user collaboration, so they're built about multiple people at the same time authoring and creating and interacting with this. But they are complex to build and deploy, so they have like the big downside. The more you try to fit so much into one system, that system starts getting bigger and complex. On the other hand, you have the delivery, some of the delivery standard, and those have more limited schemas. They don't let you represent things completely, and so you have to kind of simplify, distill in a way, down to a subset. They're mostly tailored for single assets, but they have a much more compact footprint because they're being thought about for transmission, so to deliver onto devices. And those are easier to build and deploy. And this is where I think it's the challenging moment that I believe we are, and it's exciting actually, and at the same time challenging, is to how do we guide some of these standards, and do we bring them far away from each other to really create a clear distinction between authoring and delivery, or is there a point in time where we can bring them together? And so the journey here, and I was thinking about, because I've been in conversation where like, that's to be one. No, it's never going to be possible, crazy, there should be two, or maybe many. And then I thought, okay, but regardless of what I think, I was thinking, well, what is, if Metaverse one day wants to be a digital version of the real world? I thought, well, nature is open, so it's an open system, and is governed by one standard. I don't think it changes the way it's built and defined and behave is consistent across. And so I thought and this is obviously a long shot, is open metaverse should be, in fact, having a common periodic table, so a consistent set of components that describe how you define it and how the things are actually built, and also a common law of physics, and so a consistent way that you describe how things behave between all of them, versus like, I am in one place and another one. And again, going back, I want to emphasize, it doesn't mean that they need to be matching exactly everything that we live now, but more about having some commonality that then you have a believable and consistent experience when you move between them. And that's, I think it's my talk in this.
Thank you. So we will take questions after the next three presentations. So after Steve and Natalya, so write down your question, don't forget them, and then I think it'll be interesting to talk to the three of them and have the joint Q&A. Patrick?
Hello again, everyone. The technology for the metaverse is being built by many companies, many organizations, many communities, including the game and movie communities, which is why I'm excited to introduce to you our next speaker, Steve May. Steve is the CTO at Pixar Animation Studios, where he supports all technology at the studio. Steve joined the studio in 1998 as a technical director on Toy Story 2. He went on to work on Monsters, Inc., Finding Nemo, Cars, Up, and Brave. Steve is going to share with us the origins and evolution of USD, Universal Scene Description, how it is used to make animated films at Pixar, and why it could be a foundational component for 3D in the metaverse. Steve?
Thanks, Patrick. Guido's a good friend of mine. I was sitting there feeling bad for him having to follow a famous author in Neal. And then I realized as I'm sitting there, like, now I have to follow a famous actor in Guido and a famous author in Neal. It's a real pleasure to be here. In 1998 sounds like a long time ago when we started. In fact, I think Guido and I actually shared an office on Toy Story 2, so there's a lot of stories I can talk about after that. Very excited to be here and very honored. And we'll talk about USD and the Metaverse. The Metaverse, we've already talked a lot about it already. It is clearly a very, very expansive topic. There are a lot of challenges and problems to be solved, and Guido talked about some of those. USD solves one of the problems. USD allows us to build complex 3D worlds with many users interacting in real time, using tools that we have today, but also tools that we might not even be able to imagine. USD is the ground floor. It's a foundational building block for the metaverse. USD stands for Universal Scene Description. It's Pixar's open source software for describing, composing, interchanging, and interacting with incredibly complex 3D scenes. It is the beating heart of our animation production pipeline. It is very important to Pixar. It is built by practitioners for practitioners. Our engineers work directly with our animators every day to make sure it works and it works well. We are very excited about the enthusiasm it has generated in the film industry, and to be honest, we had no idea when we first started working on it that enthusiasm would go beyond film and into other industries and the evolving landscape of the metaverse. At Pixar, we have a lot of experience creating complex worlds. We've learned a lot of lessons based on decades of R&D and animation production and trial and error, along with some success. As we scale from making shorts like Tin Toy in the 1980s to our early feature films, one of the things we learned is that a lot of data files is good. We figured out that by separating out geometry and shading, animation, and other things into different files, we enabled artists of different disciplines to work independently and simultaneously. And it made it easier for artists to reuse things like characters and props and sets and lighting rigs. But by the time we got to Monsters, Inc., we had dozens of different file types. Each file type had a different file format and different capabilities. Some had referencing and some didn't. Some had layering and overrides and others didn't. At the same time, a lot of great new commercial tools were becoming available. And this was fantastic, but they had their own file formats too. So a lot of data files is good. Like I said, it lets artists work together and collaborate more easily. But a lot of data file formats is bad. Many formats make it harder for artists to work. They can't easily move assets from one app to the next. Each format has different capabilities, so important data gets lost. Artists' workflows become inconsistent. A lot of time is also spent engineering import, export, and converters from one format to the next, and incorporating new tools into a pipeline is really expensive. Our original animation system was called MENVI, stands for Modeling Environment, if you're wondering where that name came from. It was the system we used for the original Toy Story and many of our films. But over time, it started to show its age, and including the proliferation of the file formats. In 2003, we decided to design a new animation system. This was originally called MENVI 30. It was first used on Brave and renamed Presto. One of the goals of Presto was to solve the problem of too many file formats and create a single unified scene description. This was great. We had a brand new animation system, Presto, and a new unified scene description format, which we had called MENVA, and we were going to use it for the first time ever on a feature film called Brave. So what could go wrong? It's a simple little film with a princess, castles, and Scottish landscapes, and an evil bear. Well, once in the hands of our talented artists, the new animation system and scene description format buckled under the weight of the visual complexity of that film. Fortunately, independent of Presto, we had developed a highly efficient format called TID-Scene, optimized for speed and rapid previewing. And TID-Scene was quickly incorporated into the Presto workflow. We were busy making this movie. And the combination of MENVA and TID-Scene allowed us to make Brave. And that was great. But we now had two file formats for scene description. MENVA had powerful operators for building worlds and collaborating, and TID-Scene was high performance. Alas, 2 data formats for scene description is too many. Because TID scene lacked the expressiveness found in Menva, we started adding Menva features to TID scene, but it was almost impossible to keep the features in sync, and it was a lot of work. What we really wanted was the richness of Menva scene description and the speed of TID scene everywhere. Could we have our cake and eat it too? The answer was yes, and it was USD. USD began as an experiment following Brave in 2012. We took the expressiveness of the Menva files, the performance of the TID scene files, and the composition engine in Presto, and combined them together into a single file format and system called USD. As you can see, the goal from the onset was to make USD a system that was highly expressive for authoring and also highly efficient. And I'll come back to that later. I mentioned the composition engine of Presto, so now's a good time to talk about some just key concepts in USD. Composition refers to the way that USD assets are combined or composited together to give a complete view of a scene. Composition is used to combine individual layers into larger assemblies and enables workflows to let many users collaborate simultaneously without conflict. Here's a very basic example of using references for asset composition. On the left, an asset rock is defined with a default size property, and on the right, 2 rock assets are referenced into the mountain asset. Not the most impressive mountain, I might say. Notice the size property is overridden on rock 1, whereas rock 2 will get the default from the referenced asset. The kitchen set shown here uses a more complex set of references and composition to show the image in USD view on the right. Most people here are probably familiar with image editing programs like Photoshop that create images by composing a set of layers. Layers at the top of the list are composited over layers at the bottom. And you can turn visibility of individual layers on or off, and changes in one layer don't affect other layers. And we call this non-destructive editing. It's very, very similar in USD, only instead of images, the layers that are composited are 3D geometry, animation curves, material properties, light sources, cameras, and much more. With USD, a shot in a film, in our case, can be comprised of separate layers for each department. So each department can do their work in their own layer and do it non-destructively. That way it doesn't impact the work done by other artists that might be working at the same time, which is very, very common. This allows multiple departments to all work simultaneously, and in this way, USD is fundamental to supporting artist collaboration on complex scenes. USD also knows how to composite these layers, so values in stronger layers override values in weaker layers. For example, our layout department creates the staging with rough poses for each character. After layout, animators do the work of the final character animation. The poses from animation override the poses from layout because the animation layer is stronger than the layout layer. Meanwhile, sets and effects departments can be working at the same time as the animation without stepping on each other's work. And the number of layers is arbitrary, and USD puts no limit on it. So each department can have as many layers as they want. And for our case, in animation, it's very typical to have separate layers for each character so that different animators can work on different characters at the same time on the same shot. Now, here's an example shot from Brave, kind of visually represented here. It's comprised of multiple layers of USD which pose the characters of Merida and the bear Mordu. The shot layer references the model layers. And each model, like Merida, has references to separate layers for body, geometry, hair, cloth, materials. A character artist can modify the geometry or shading of Merida in the model layers without breaking animation's poses. Each character model references layers for the underlying articulation rig. And each rig is made up of layers too. And any layer can be referenced multiple times. So in this example, a generic rig for a left leg is referenced by Merida once and by Mordu, the bear, twice. Any future fixes to that left leg will actually fix both characters. And the process by which the layers are combined is called composition. So let me give another example using our friend Squishy from Monsters University. He's having a good time. Imagine we get a very late note in production to change the shape of Squishy's horn in this scene. So there's that little red drawing indicating the note to be done. But the movie's almost done, Animation and lighting are done. Squishy is in many shots in the sequence, and the last thing you want to do is break a bunch of shots that are mostly done. And the good news is that USD and layering gives you multiple options for changing that horn. So here we are in Presto, our animation system. We have 2 shots from the sequence loaded, 1 shot on the left, 1 on the right. We can play back either one. So on the left, and there's the other shot on the right. And if we work in the shot layer and make changes to the horn geometry, it will override the shape of the horn in that shot. So note that changing the geometry in the shot on the left does not affect the shot on the right, and vice versa. But instead, if we modify the geometry in the sequence layer, the thing that contains all of the shots, it will affect all of the shots in the sequence. We can also load the character model itself. We can load Squishy into Presto and edit the horn at the character level, at the asset level. And this will then modify all of the shots in the film that have Squishy. And lastly, look at the bottom right. So here's a horn model, and this is a horn model that we could reuse across different characters, and it's just the components that's referenced by Squishy. The change this change here would affect all of the characters in the film that actually use this horn. This is the power of layering and referencing operators in USD, and layering applies to everything. Character models, cameras, lights, set dressing, animation, shading, materials, you name it. Let me talk a little bit about complexity. This is the antique store from Toy Story 4. It's one of the most complex sets we've ever built. It has thousands and thousands of individual props, but it's part of an even bigger set, which is a surrounding town and a carnival out front. And this video, if you're familiar with USD, this is USD View. It's an interactive viewer that comes with USD. This allows an artist to browse, and here you're seeing an artist kind of actually move through this entire town and the carnival, and then move inside the antique store, where every prop, down to the very smallest prop, even like down to the buttons inside the jar in the corner of the shelf in the back of the room, can be inspected and modified. We estimate that at Pixar, like USD allows us to build and interact with scenes that are 100 times more complex than we could before. There is some debate about the role of USD. We feel really strongly that it can be used for authoring and for content delivery. At Pixar, we have to deliver full fidelity assets and cache animation to our large render farm. So we are very concerned with things like network bandwidth and the time it takes to get the assets to the renderer. We render thousands of frames of animation every day, and the performance of USD is critical to that. There have also been comparisons of USD to Photoshop document files, but they're actually quite a bit different. The main difference is that USD is a web of deferrable documents, and composition is used to consolidate those documents, and that can add some cost. But we think the composition system is a key part of why you want to use USD, and the operators directly support high-performance access to large virtual worlds. USD's variants, payloads, and powerful asset system give world builders immense power and flexibility. And any USD file can be distilled into a single flat USD asset. USD also features highly efficient technologies for geometry, including Open Subdiv and Draco, as well as deferring processing of data only when it's needed. Despite USD's rapid adoption, there are challenges. One is the belief that USD is too complicated. We know this, and we are working on it. We're excited that USD is coming to the web, as partners like Autodesk and Adobe and others require it for cloud-based web apps. USD does have complex semantics because it solves really hard problems. But we believe it is possible to create a specification, perhaps an open standard that includes core features such as layering, referencing, variants, and instancing. And USD is rapidly evolving. We have big ideas and want to innovate quickly. At the same time, we're committed to working with the USD community, and we really firmly believe that input from the community will only make USD stronger and better for all of us. So what does the future hold? This course is supposed to be without the hype, so I'll focus on the facts. USD is a language for large-scale data modeling and world building. It is how all the components of Pixar's filmmaking pipeline communicate. It provides nouns that clearly describe the data in our scenes and how individual bits of data are defined by each other. It provides verbs that tell how to assemble simpler data into even more complex data. USD enables massively concurrent collaboration. It provides a way that everyone can collaborate on the layers in a scene to express opinions, choices, and even overrides. USD is optimized for performance. It comes with an efficient and quick engine that allows inspection of the very smallest prop in scenes that contains millions of individual objects. It comes with tools for peering into and modifying the data so you can create new behaviors, like adding physics. And it comes with a high-performance rendering system called Hydra. And last, USD is an actively developed open-source software architecture. That means that not only Pixar, but everyone who adopts USD into their systems can see exactly how things work, adapt it to their unique needs, and then propose those adaptations back to the USD development community so that everyone potentially gets those new ideas and specializations. Disney. I think it is a fact that the Walt Disney Company is uniquely positioned to create compelling content. We have stories and characters from talented artists and filmmakers at Pixar, Lucasfilm, Marvel, Disney Animation, and more. Disney has theme parks, hotels, resorts. There was a cruise ship out here earlier in the week. They provide the perfect kind of place to bridge physical and digital experiences. And Disney has core technology, like USD. Pixar is very, very committed to USD, and we are doubling down. We have recently announced that we're growing our USD R&D team. We are hiring. And we have two primary goals. The first is we just want to move faster. We want to increase the rate of innovation and development. And we want to expand support for the USD community. In particular, we want to better facilitate external contributions. And we want to expand our ability to support the community and facilitate open discussions about new ideas and proposals. Patrick, our course organizer, asked me to talk about convergence a little bit. So I'll say a few things here, and I think Natasha is going to talk more about this topic. Convergence of film and games. When I say games, I really mean games and any kind of interactive content. I believe that there are different axes of convergence. It's not as simple as these things are converging or they're not. Film and games are different forms of art, like films and books. The ways you tell stories with them is different. From a medium standpoint, therefore, I don't think these are converging. On the other hand, the tools for creating the visuals is clearly converging. There's increasing overlap, and both film and games are benefiting from the advancements of the other art form. And last, we mainly think about and focus on technology for making the visuals, creating the pictures. There is less talk about the tools we provide for the writers, directors, and story artists. We also have to think about the technology we use to craft the stories. If the story isn't good, we all know the visuals don't matter. And because films and games are different means for telling stories, they will probably need different kinds of tools. So where are we headed? Well, this is an incredibly exciting time for computer graphics, for USD, for Pixar. Internally at Pixar, we're using USD in really cool new ways and leveraging new features that create next-generation tools for our artists and our animators. And externally, we are inspired and we are grateful, and we're benefiting from rapid adoption of USD and partnerships with industry leaders in film, gaming, VR, AR, GPU, mobile, and many other fields. And lastly, there's enormous potential for good to tell stories and connect with our audience in new and positive and meaningful ways. And there's a lot to be excited about. Thank you for your time.
Thank you again. We'll take questions after the next presentation. So I have the immense pleasure to introduce our next speaker. And And our next presenter is indeed a SIGGRAPH legend. She's been actively involved with the graphics community for the past 20 years. She's been running the Advanced in Real-Time Rendering in Games course at SIGGRAPH since 2006, and that course was inspirations for today's course. She's been a SIGGRAPH Games chair for a couple of times. And for the past 6 years, she's been doing graphics and Unity, and it shows a little bit too much to my liking at times. So please welcome Natalya Tatarchuk.
Thank you, Marc. Thank you kindly for the introduction. You probably see a solid color of blush. It's composited in real time. So thank you for inviting me to the course. I know it's been an honor to be part of this exploration. And in a way, some of you who may have seen me do sort of open problems course, I feel like this course spiritually has the same notion, because we're going to explore a lot of the topics without necessarily stating the solutions. We're here to foster the conversation. At least this is why I'm here. And I'm a little bit of an interloper in it. I'm a computer graphics nerd, and Metaverse seems big and odd and complex. So anyway, as Marc said, I'm Natalya Tatarchuk. I work at Unity Technology as a Distinguished Tech Fellow and Chief Architect, focusing on artist tools right now and the path of creation of content to real-time 3D. And today I want to talk and really just share some of the thoughts that are related to power what I call actually Creativerse. Like I said, I'm an interloper in the world of Metaverse. So some of my opinions may be aligned and maybe not aligned. And the results of what I'm going to share with you, honestly, is a result of many conversations. There were tons of discussions, so I'm not going to claim these as my own. It's a reflection of collection. I'm going to talk to you about composability, and guess what? This talk is heavily composed of many other ideas, and that's really the main theme. That is to stir the conversations on the subject of what is it going to take to power the Creativerse. And speaking of that, holy ... there's many buzzwords. I just dropped a new buzzword or old buzzword on you. What the heck is Creativerse, right? And so many picture, Metaverse is sort of this immersive world of virtual reality, and this was sort of a picture that I had in my mind about it. But I lean into, this different concept of Creativerse. Like those who know me for many years know that, one of the foundational drives I have as a professional is just empowering artists. Really everything I've been doing in my career, only later I realized was actually driven by that particular very simple urge. And so the reason I prefer thinking about, Metaverse as this interconnected thing is, and we talked about the openness as a necessary form factor and philosophy of creating, not a walled garden, but I want to see the future where people are creating dynamically, independently or together, and using variety of tools, software or physical tools that let them create without boundaries, really using their imagination with the best tools that let them, that meet them where they are, how they want to create and compose these digital worlds that really are the foundation of this Creativerse. And I'm going to argue with Guido, I don't think it should be consistent as nature. I actually want to see phantasmagorical, the strange, the weird, the AI generating things we haven't dreamt of. So we'll have to explore how this Creativerse, what are the internal rules that it creates, because we want to give maximum freedom to the creator that is going to compose this, right? And just to be clear, it isn't about gaming experience, right? It isn't about, like when we talk real time, there are many different ways to experience this from variety of domains, industries that are all powered and really thriving in experience in real time. And in fact, real time is really the next big shift. Now, today you've heard, Web 3D, Internet 3D, so I kind of think about that subject as, if we look back at the original Internet, it started as text, right? And then pictures were introduced, video was introduced, and we're at the start of this 3D Internet where the core concept isn't actually how it's rendered. The core concept is how is it interacted with, right? And that's what's fundamentally different about that. We primarily also, speaking of that interaction, access the internet through our laptops, smartphones, so untethered devices are often the main way. And in the same way, when we're going to experience this creatorverse or metaverse of tomorrow, we're going to see that experience, and it's going to, I mean, my kid is 6, right? And she's accessing this far more through, again, a smartphone than anything else. And I'm going to argue that, and this might be a really, bombastic statement, but none of us actually will know what metaverse or creatorverse will look like, because it's the kids like her who will actually be creating. We have no freaking idea what they will be creating, as I didn't 20 years ago, or 25 when the cave was around. And so it's not a singular place, but it is about individual experiences that are shifting into connected, collaborative experiences. And to Guido's point, we don't know where that will be experienced. It might be a hot, like I was born in a very remote area where it was like 6 hours to drive in a car to get to a big city. But we want those creators to be a part of this too. And like he said, there's a lot of limitations in how we think about content creation in that world. And the core theme is, rather than a static experience, it becomes interactive. And of all the components of the metaverse, right, that interactive real-time experience is the most important. And that's an order of magnitude steps ahead of most, like what we are currently experiencing with the current content. And compared to 2D content, which is static, fixed, even videos are effectively that way. Real-time is a media that is alive, right? And it has different rules, it's interactive, and in a way to think about that, we give the users the control, the precise control over the experiences. And this is where, for me, this is grounded in video games, because this is when you don't know what they're gonna do with the content that you so carefully crafted into perfection. And they'll go and look left, or as a graphics engineer, you're gonna look at the friggin' ground, and people will shoot you, and then you'll look at the leaves and so forth. But we all live in this real time, right? And no one knows, as these experiences unfold, what will happen next. And it's the same with this Creativerse real-time 3D. The next event we experience isn't going to be predestined. And this is a really important thing when we think about creating for it, the content generation for it, because it's going to spontaneously arise out of our action, out of the actions of the person who is going to be experiencing that and interacting. That media is alive, and it's a fundamental shift. Now, the other aspect that I'm excited about it, one is about creations, but the other is about experiencing. And so if we could work together in real time, anywhere, on any device, collaborating seamlessly, independent of where you are in time, space, time zones, distance, what does that help us bring in terms of vision of the future of what we can create? And if we have simultaneously tens of millions of creators that are instantly creating objects, whether it is by scanning, Nerf is taking everybody by storm on the ability to recreate the fidelity of the underlying source object, right? To create the interactive experiences that are so easily crafted, and then place them in that world anywhere, right? For anybody to connect to collaboratively. And what if we could link also the physical and the virtual world in novel ways? And this actually can be some of the projects that we're involved with are focused on making energy safer, to make it more efficient, to make it more sustainable. That whole conversation about NFT and the carbon footprint, to help simulate effects of traffic, right, on the city and monitor autonomous systems. This is huge. And then we also can conduct, as engineers, limitless research without actually engaging with physical world. It's funny, and one of my early jobs was this startup company that had a 6 degree of freedom, 6 foot steel arm. And this is where I learned the power of divide by zero, because our engineer didn't clamp max force on that thing. And when somebody threw an exception, it whacked you. And you were like, okay, divided by zero, super important. But what if you didn't have to suffer? Valuable lesson, but painful for a lot of the folks in that company. And what if you can actually do user testing to validate these ideas virtually, right? And that's a fairly exciting future to think about. But getting back to our concept of Creatorverse, what is needed for its creation? And there are many elements. I won't have time to go through that. But in fact, I kind of drafted the simple, and this is an oversimplification, simple equation. When thinking about what it's needed to power it, I kind of break it down into two components, right? Composability and portability. And so if we think about, effectively, this is the next generation of the internet, and I'm purposefully divorcing myself from identity and blockchain and everything else for the sake of the conversation. At the heart of this, like I was saying, this is about the content coming at the hands of the users, that experience part of it, across the boundaries of applications, right? So this is not about a unique place where this content was created for, and that is the heart of the deepest need to power the creatorverse. And a different way to think about this equation is here. If we think about the internet, and frankly, if we learned anything about the 2D internet, right, it's very simple. Content is king, queen, whatever monarch you prefer to choose. We see this from proliferation of all the social media, regardless of our opinions on the impact of that, YouTube, TikTok, anything else, or frankly, the vast amount of content that we need to consume, or we love to consume as players of live games, right? Real-time 3D content powers the creativerse. And I want to take a very simple example. I was thinking about, like, what are the things that I really want to anchor my understanding in? This is when I was going through the journey. And so I picked a very sophisticated example, a meme. We're all familiar with the concept of memes. I don't have to explain it to you. Image goes viral, people mod it, they send it out, they instantly copy it, it goes through. And so I started thinking, okay, well, we are talking about this real-time 3D experiences. What is it going to take to create a viral real-time 3D experience with the same rules of engagement as a 2D scheme? And my brain started exploding on, like, what it actually means in practice. And I don't mean a movie. I mean a URL, like, so those of you who play instant games on the phone, right, that's a kind of the same notion, but like expanded out to a proper 3D experiences, maybe with a controller, et cetera. And it seems like a very simple concept, but to have people participate in a wide variety of ways to create it, a fair amount of complexity actually needs to be resolved. And so some of the elements that we want to enable, it has to be easily shareable, instant shareable, right? That whole notion of URL, right? I post it, my mom gets it, she can access it, she doesn't need to think about, like, oh, did I plug in the controller, et cetera, like all these complex steps that we need to do. It should be as simple as cut, copy, and paste, and a re-experience, right? And if the content isn't small, like the GIFs are super tiny, so that's great. Real-time 3D, aside from super low, like instant games, is quite hefty. Where does it live? Who sends it out, and how are we going to stream it and get it to the device, and what format and what memory footprint? The content needs to be collaboratively modifiable. Like, it's not enough to have the sad puppy, right? You want to have a word or some sort of sentence that changes your experience about what it tells you. What is this all about? Right now, we're all puzzled. And so we need to be able to actually enable how people will modify the real-time experience. And it also needs to be portable. I mentioned I want my mom, my daughter, anybody else, in the family, et cetera, to experience. I have no idea what devices they have. Right? There ain't no guarantee that they're going to be sitting on a PC or on a console, and it needs to be consistently experienced on a variety of platforms and applications in real time. And that's a non-trivial requirement for, again, that experiential part. And so we get back to our equation of creativerse. And I want to take a deeper dive at these components. So we'll start with composability. And before I move to the next section, I want to have like a tiny interlude on standards, and Guido touched on it a little bit. I simply believe that there isn't a need for one standard, sort of the ring, right, for this creatorverse. It's very tempting to start arguing in fisticuffs on like USD, GLTF, something else. And at the risk of oversimplification, I think we just need to pick what are the clusters of importance and then find 2 or 3, 4, standards that cover that. And so here's an example from 2D world. And those of you who've been around the block remember how many standards for 2D representation there were. Iris, I'm looking at you, and so forth. Like, I went back and like scanned back my career of writing image importers, right? And many of them died on the vine, right, for many good reasons. Because the formats that ended up surviving, winning, kind of tended to occupy key clusters on kind of this triangle. And this is my opinion, so it might be totally different for others. JPEG brought ubiquity and compaction. PNG brought portability, but then lossless quality due to its improved representation. It's still compact. And then we have formats that are focused on precision, right? Like they really bring the, EXR, TIFF, and so forth. They really bring the aspects of representation accuracy. And so we have a few axes that are really important in order to cover a really wide gamut of representation needs. And so we need to define the same thing for real-time 3D. What are our clusters? Maybe it's going to be interactivity, size, precision. Because if we're trying to represent, let's say a 3D version of Paris, Really helpful if it's precise for autonomous driving. If I'm doing some sort of non-photorealistic game like Slime Rancher and so forth, precision might not be super critical, right? Or maybe the different axis is collaboration, right? And maybe a different axis is portability. I actually don't know what they are. I have opinions, but we're gonna explore this and it's gonna emerge. So back to this theme, looking at the first element, and I found a series of Medium blog posts from John Radoff that I highly recommend you guys because it was a tremendous jumpstart to thinking about this in a sort of systematic way. And specifically, one of the blog posts is about the fact that composability is the most powerful creative force in the universe. And it's really true if you start thinking about it on that deeper level. And as John says in this article that I reference, compose, component, combine, compound, composability. All of these words stem from the same common Latin root, com, meaning together. And what we can accomplish together is more powerful than any of us can do alone. Composability in the metaverse. And this is another reason in part where I kind of prefer to think of metaverse as that creator-verse, because it really sits in the power of that statement. One of the most powerful things about 3D internet is in fact its composability, right? Combined with that experiential interactivity that is going to enable the creative potential in all of us. And I'm gonna think about this as a positive optimist. Yes, social media moved on to a different space, but it's going to unlock far more than we can individually create that we've seen before. And so when we think about composability, we can break it down into two other elements. Composability of authoring, so this is composability of content, and then composability of experiences, and both are critical in order to enable that. And so how do we approach enabling better composability for content at authoring time? And this is a huge challenge. You just heard, some of the previous speakers. Steve touched on the issues in film. This is a major challenge for pretty much anybody who's trying to tackle this. And here's a perspective of what I believe needs to be true for content creation for real time. Honestly, whether it is real time or offline doesn't really matter because these are fairly fundamental principles. And I'm not going to read anything in the slide, but I want to ground this discussion in the real goal, right? Which is to support content creators. And so I think this is what good looks like, fundamentally, when speaking for tech for content creation. Those are really good guiding principles. And this is one of the reasons I'm also in a camp of wanting to anchor the effort and achieving composability by looking at USD. Now, it may be the format that wins, it may be that there will be forks and things like, I don't have an opinion about that, but there's a lot we can do in that format now, which is very relevant to that composability of real-time experiences. And we see that those experiences are all about content creation, and USD was, as Steve just shared with you, was in fact created for solving these exact problems. And all of the properties that are listed here are highly relevant to real-time 3D, game development, or other experiences. And it's a system that has been proven to work and has been tested in productions with, well, frankly, billions of dollars on the line, right? Not chump change. And so if we take a quick look of what it means to make content with USD, with a few concrete examples, we can start by looking, okay, let's take a look at a large scene, right, and ask how this is assembled. This is from our wind-up demo, but you can equally look at something from the physical world. So here is the 3D Paris represented in real time, which is significantly more heavier. And then I'll touch on some of the examples from Weta Digital that really push the complexity to the crazy level. It's equally valid to look at scenes even at this scale, and I modified an image from Dreams because also Dreams is sort of the canonical example of the composability when I think about the North Star. And so if we look at this scene, just start with the light bulb asset, right? It's modeled in Blender, it's exported to USD. Now, if we look outside of USD for the current FBX workflow or BJ, if you want to sit there, this is it. You're done. Moving on, nothing to do. But as Steve mentioned, USD has this concept of layers, references, overrides, which enable multi-user collaboration across departments. More importantly, it also enables flexible pipelines, back to that example of the shot that is modified late in the game and the pain that really represents to the real productions. And so we can export a high-fidelity bulb.usd file, then run a post-process to generate, let's say, your LOD level of details, as well as different material configurations. So, for example, shading when the bulb is on, when the bulb is off. We don't need to bake out 6 different permutations of this asset, which you typically do right now in a lot of the pipelines. We have one version, and the USD composition actually enables sparse overrides. So in other words, the compaction of data is achieved because you're only changing the element that is different, right? And USD variance sets, they enable the dynamic switching of this content based on the sparse representation, only loading what you need for the selected variant. And that's a very important thing for composability. Versions can be represented as a variant set as well. It enables the asset to encode the published history in the asset itself as well, keep it live. So multiple versions can be used concurrently by switching the version variants. And those of you, and like it's funny, we just released a showcase, and so like all of the previous week and the weekend was like, oh gosh, which version is the right version? Where did we fix the artifacts and where did we not fix the artifacts? So this is so important for true production composability. That asset then can be published to the asset library, which typically has integrations with DCC tools, Maya, Blender, Houdini, you name it, that allows easy use for this asset across all the applications, with the compositions and override carrying through to those DCC, keeping the consistency. And of course, each tool has its own way of rendering, right? Like we touched on the need of Hydra rendering. But another huge benefit of Hydra is the actual portability of visual representation that it allows you to do, because without that, the assets ends up looking quite inconsistent. And as a user, you kind of feel like you can't trust what you see. Is the artifact because of the weird rendering, or is the artifact an underlying source asset? But Hydra rendering protocol lets you plug in the renderer into each viewport so you can see exactly what you see is exactly what you get, right? And it enables you to use your rendering engine, right? And I'll give you some examples from the Weta Digital pipeline, where you have consistency now. And many game studios have done this in the past, but it was a tremendous effort to keep up with the changing APIs. Rendering APIs of DCC became significantly more complex for the viewport functionality. USD payload is another mechanism that enables us to reference heavy assets into the scene, but defer loading of the actual data, so interaction is fast. And once the asset is loaded, we still only pay for the variants that are actually selected, and then, even then, the data can be streamed on disk on demand. So you only pay for exactly what you need to get your job done, which is non-trivial, and the sizes, gigabytes almost is a forgotten past. We're in terabytes and petabytes, right, in a lot of the content creation. So this is important because hardware sure as heck is not scaling to the need of these data sizes. USD sublayers allow multiple users or departments to work in parallel. And layer, like Steve mentioned, layer muting also allows users to opt out of seeing some of the changes, right? And any edits to the scene, so for example, changing the light bulb color, is only a sparse difference over the composition structure, which is alive. Sometimes you need to see an asset, but don't actually need to edit it. And just the possibility of editing brings in a lot of the expensive representation. And so with deeper integration of USD and Hydra in the DCC tool, you can create a workflow where the object is visualized, but it's rendered out of core from the perspective of host application, which creates a sort of, you can think of it as an edit time hlot, right, for authoring, where you bring in all the actual details that you want to edit, but everything else is visualized without having to have that in memory. Now, so far, we only spoke about static construction, but we can imagine very easily, well, back to that real-time 3D experience. We're building a game, we want breakable props, and of course, you can do this by hand, but you probably don't have just one breakable prop, so you want all props to be consistently breakable. What does that look like in terms of pipeline? And so we model in Blender, we shade in Substance, and this is just an example. We run an automated fracture sim in Houdini, as a lot of people are doing that in the industry right now. And then we finally publish to a content library as a published version. And the USD scripting API actually allows you to write a pipeline code in a normalized, data-driven way that is decoupled from runtimes. And then we have a pipeline for making any prop breakable that is consistent. So how does that translate to game content creation? Game developers have a content creation workflow that looks very similar in terms of a lot of the tooling, DCC applications, to visual effects, films, digital twins, and many others. However, the end goal, right, involves a massive ecosystem of platforms, each with its own set of constraints, quirks, and requirements. For example, if you compress textures for a mobile phone, You might need a different compression algorithm depending on exactly the model. Are you on Android? Are you on iPhone? Which specific Android model you are in? Content needs to be appropriately scaled and LOD'd for performance reasons. And then also the fun favorite of anybody shipping on mobile, or PC for that matter, driver bugs, right? They're abundant and you kind of need to change the content. Maybe the shader code needs to be different, especially in the mobile world or in some of the untethered form factors where you can't rely on the user, go and update the driver. And so in that world, similar to the offline rendering world, there's typically a source representation, which is tied to a specific tool, DCC representation, and there is a canonical representation, which is consumed in a game. And previously that would be like OBJ or FBX, right? But there's also a build of those assets that gets shipped with the game. These file formats are actually the most used containers on the, content containers on the planet. And a game engine will have its own build format, unique, pretty much typically per target, per platform, sometimes even per variations of hardware on that platform. And the game itself may also have a unique file format, and it could ship with the engine's binary data. But it also can be a bespoke format for user-generated content, and there's tons of examples here, of that in the industry at large right now. So this anchors us in a lot of the elements of composability for authoring for games. But as I mentioned, and actually this was touched on by Steve, there's also this whole convergence of film, digital twins, and other applications. And it's all sitting in that convergence to real time. I will not cover that in depth because frankly, and Marc, I'm sure has seen many deep presentations on this. This is a topic for its own course, let's be honest. But I wanted to touch on one element, which is back to that composability that is relevant for not just game productions, but of course to many other cases, VFX including. And it's also relevant to the story of Creativerse because we have such a strong conversion of experiencing film assets in real-time experiences. Disney was a fantastic example. It does cross into physical world, but it also crosses into untethered world. There are many other examples where we want the flow of content authored once, getting to a variety of experiences. And again, that to me is a really fundamental principle of Creativerse. And so if we explore that journey a bit, there's very strong emergence of USD-based pipelines, especially in this moment in times in VFX. And in fact, I think today there's a really big council that Rev and team are organizing to discuss USD very strongly. And an important theme to note here is there's a convergence of USD authoring pipelines that allow and empower creation of stronger interchange of content between the offline world and the real time. And this in itself is, again, a rich topic. And so I'll just share one example of how composable USD-based pipeline, this is a peek into an evolution of that as well as sharing tooling ecosystem, can foster stronger film and real-time convergence. And so we don't have to look far, right? For example, and there's a couple folks in the audience that, Paolo talked about it at DigiPro, and he'll talk about it today later on. We could look at the Weta Digital pipeline used for Weta FX productions. And what you see here is various stages of production pipeline and realms connected to each other, right, of different phases of the creation for the particular production, showing that the data flows in and out of them, going downstream and upstream, quite complex, but as required for the production needs. And these effectively map to sort of, mega departments that contain the actual departments. So for example, shots can include lighting, composition, matte painting, and so forth. And so where would we start introducing USD in this pipeline for content creation? And what Weta Digital has discovered is the higher we start in the pipeline, the more work we have to do to make it available to downstream departments. So for example, when Weta Digital rebuilt the lighting pipeline to be USD focused, as lighting, so that was one of the reasons as lighting in the shots team was a really good integrated point for starting to test it out, because it's the workflow that assembles all of the pieces together to render a particular shot. And in particular, when we look at the production of Weta FX, lighting is a broader task, and quite often it requires a mix of content authoring tasks, jumping across many different DCCs, multiple tools as needed, touching on the very notion of composability that we're really keen to enable. And so we can see a lot of the benefits we touched on, layering, variants, and so forth, in this particular pipeline. And the idea was to make sure that in general, A workflow in lighting would require every component to be in USD form. And we can start experimenting with publishing USD layers to let lighters reload them when sharing, light rigs, for example, or sequence level settings. And so the plan was to convert every published component in a USD representation. Now, I'm not going to break this down in depth. I really suggest that you go to the talk today that Paola is going to give you a lot more details on this. But effectively, one of the benefits of this pipeline is a broad-end composability and portability of this content to allow, anchored on the standard representation of USD, to allow interoperability by bringing this content to different, visualizers. For example, here we have this content, Weta content rendered in Unity, Unreal, Blender, and other DCCs. And this can be supported everywhere that Hydra Delegate is supported, right? And this supports meshes, materials, and so forth. And at the heart of it is the representation in USD for the many different assets that are created by various tools. For example, environment vegetation tool like Lumberjack, or the hair grooming tool like Wig, and so forth. As long as you represent them in the underlying geometry that is integrated with the USD format. And so here's an example where, make sure it's playing, where we effectively needed to integrate the prim adapter into the USD pipeline and connected it to Hydra delegates for preview. And in order to enable it, a lot of work had to happen. We had to integrate SDF file format plugins, update the schemas, prim adapters to make sure that all of the procedurals, Wig, for example, is the hair and grooming, fur grooming tool, were able to represent this consistently. That is going to deliver the generic Hydra prims that any Hydra delegate is going to be able to consume to enable the portability. And so here you're delivering, fur and storm. And so what does that accomplish? Back to anchoring this USD composability is effectively connectivity of authoring to the real time. And we start and end with tools, and we end with composability of that content. I mentioned the need of flowing the content that's authored that you minimally change to, but compose very freely. And so here is an example, and this is new, we've just released it today, where we used Wig to generate the filmic assets, such as lines, hair, and fur grooms, using this exact pipeline. And then this data was brought to the engine for real-time experience. And as you can see, the authoring of the data is, very heavy filmic assets. For real-time experience that shared these underlying assets, enabling stronger conversion between film and real time, enabling better composability. And similarly, we also used it to author filmic rigs, right, using Ziva VFX to generate super advanced biomechanical anatomic rigs, but then being able to bring that through to the real-time experiences, which increased the composability by bringing the simulation and deformation, but at the same time bringing the interactivity. And so you can see here some of the fidelity that this set of tools allows. And then, and I'm a graphics nerd, so even if we're talking about Metaverse or composability or anything else, we have to show some real-time graphics. Otherwise, it's just wrong. And so this was an experience that was running at 30 on PlayStation 3 that, demonstrates that composability element of authoring, of using the filmic rigs, of using the filmic procedurals, the hair and fur from Wig that flows through this data pipeline, that ends up running fully dynamically and can be experienced in real time. And I'm going to show you a little bit of, sorry, let me turn off the sound. Nope, I can't do that. Can you turn off the sound so we can go to the next? Because we might have sound, but we don't. So I'll just show you the experience of, like the actual modification, and there you can kind of see how, as we move around that interaction, right, that we will enable somebody to do. And my daughter was watching us working on this demo. She walked in, I have a 6-year-old, and she's like, Mama, right, can I tussle the Papa Lion's hair? Like, that seems so much fun. And that element is what gives the immersion, right? That's the actual thing that we're trying to create in this Creativerse, because she's now immersed that this is a sea and there's a Papa Lion and a cute cub, and maybe she feels to be a cute cub. And that's the ultimate power of the story, right? The shareability of content authoring tools. And now, if you're interested to learn a bit more, there's a session today at 2:15, and then in advances on Thursday, we'll also cover a bit more. And so with that, now we get to the other critical element of the Creatorverse, composability of experience. And there's a living, breathing example of composable real-time experiences that we can immediately think about. And I was kind of thinking Marc would wear the shirt from his game, but he didn't, so I'm going to use a different example. In these days, the user-generated content live games means that shipping a game is not one and done, right? There's a lot of debate about live games and the complexity there. And this is the progression from a game that ships once to a game that has sequels, to a game that has DLCs, to live games that have constant events and update. And I had the joy to participate in the creation of one. This is a game that I worked on, which is still a living, breathing world. Destiny 2 is a live online game that is consistently shipping new content, delivering a steady stream of updates, events throughout, with many playable characters, new gear, each season adding a lot more functionality like emotes, maps, audio, weapons, constant stream of events. And this data is streamed on demand based on what's actively used by the people you're playing with and, well, your own choices, right? Which brings me to the next point, which is if you don't believe the read efficiency at the level of 30, 60, 120 FPS read efficiency is critical to the user experience of Creatorverse, I just want to highlight that the hero feature of PlayStation 5 and Xbox Series X was an SSD drive, right? And this is how critical it is for us to create that immersibility. And this is another example of an app, VR Chat, that is based on user-generated content that was created using a Unity-based SDK. And then a similar example, Tilt Brush, that created a content in-game and then enabled users to export it out, composability out, to upload it to Sketchfab and Google Poly and so forth. And in the case of Tilt Brush or VR Chat, you could argue the USD isn't needed, right? You could say, okay, well, what about the delivery mechanism? Well, no, this is not, the engine could do that type of composition. For example, you could use prefabs in Unity, congrats. But then the assets are tied to engine versions, and they're tied to engine features and to the underlying schemas of that particular build, which means the content is stuck where it was authored. And this is the reality of all engines. It's not a Unity thing, any engine. And even if you're able to take the engine upgrades, which is not trivial for a lot of cases, often it means in practice creating a giant patch that's now walking the whole content that people need to download. And it means that the engine has to be loaded at every stage in order to create a composable pipeline like this. And even content from different engine versions can't be mixed and matched, which is another element that we want in composable Creatorverse. And so all these real concerns are very important because in reality, another way to think about Creatorverse is to realize that it's a giant galaxy of live games. This is an oversimplification, but that's the reality of it, I think. All interconnected in some ways. And to enable this portability and composability of experiences means that we're going to have to enable real-time 3D content to be treated as first class on OS level, which is, by the way, not at all what we have, right? Not the story right now. And to get there, we need a fully interchangeable file format for real-time 3D that is actually commonly understood by all applications in the ecosystem, which is, I censor myself, a rather crazy notion, right? We're saying that it needs to be interchangeable by all applications. The implications of that are pretty staggering. We need to be able to cut, copy, and paste any of this content easily. And this is bombastic statements. I know I'm living in a world of, you're completely crazy. You're right. No matter what the source application, no matter what the destination is. And we need to connect that to interactivity. And that requires a truly interchangeable file format that encompasses not just the static description of the content, but expressing interactivity aspects. This is important to enable the real-time and interactive content in a wider ecosystem. And so if we look back at real-time content creation, USD, we bought into composability of authoring, awesome. And so let's look at the deeper look of where it needs to go in order to enable this North Star. Now, game devs, real-time live experiences, deeply care about runtime performance. So all of the elements on the slide were called out as a particular cause of concern for being able to integrate that. So that needs to evolve to more performance, efficiency, and so forth. We also want to stress that platform-specific builds are a recurring issue that really block USD adoption, so we need to find a solution to that issue. USD schemas are fantastic, but they're deeply tied to a specific build of USD. So if Maya has a USD install and Unity or Unreal has a different USD install, which is pretty typically the case, you need to install schemas in both. Schema versioning is also completely missing currently, which makes it hard to evolve schemas robustly and keep assets decoupled from software versions. Animation curves is a whole, hornet's nest, or really, can of worms, pun intended, that are cited as a major oversight, missing from USD and the material system. There's a really thriving discussion on USD mailing list about just like, what do we standardize animation curves on? Material system currently doesn't support portable materials. USD preview surface is fantastic, but modern games need more than the PBS, Uber shader. And there's a lot of discussions that are happening in this field, and I'm kind of hoping the material X will just land in USD, and it'll be a win for everybody because we can settle and we don't need to support yet another file format, back to those formats clumping. And it solves the material portability in USD, bolsters material X adoption, and we move on. Now, to make portable content and games, we need the ability to execute scripted behaviors, which is a huge can of worms, so we need a lot of the elements described here. And we need that to create immersive experience in real time. And this is actually the very thing that one imagines Metaverse to be really good at. And when we look at USD versus web, one aspect that is missing from USD is any kind of execution that's purely declarative. This was a design choice, but if we look at comparing USD static assets to HTML, in a way you can kind of think of it as USD right now as a static web page, right? We load static assets, visualize them, it's fantastic. But if we think about the evolution of the web and map them to USD, we need to bring composability mechanism to kind of mimic the style sheets provided by CSS. What about the JavaScript equivalent? What is going to happen with componentizing behavior and creating callbacks, on-click, and so forth? There's a lot of effort happening in this field, but that evolution needs to settle as well. So there are many main areas that are needed for USD to get the full path to real-time 3D support. Material support, dynamics, procedurals, performance, behavior, scripting, and there's a lot of conversations that are happening right now. And this brings me to a conclusion, which is with all of this, there is a lot to do to prepare for the evolution of the representation format for the composable creativerse. USD is a fantastic choice, maybe there will be another, but all these elements will be required in order to be able to describe the intent. And likely, based on history, it's going to take another decade to develop, lend, settle, standardize, and that's what we ultimately need to power the creators of tomorrow's creativerse. So I wanted to thank a few people who were really key to contributing discussions, ideas, thoughts to this, and then of course I want to thank Patrick and Marc for allowing me to speak in this course with full trust of any crazy ideas. And of course, thank you guys for listening to my talk. And I think we now will have questions for the mega group.
Absolutely.
Maybe a couple.
So it was an interesting set of presentations. I think you've seen some common themes, you've seen some diverging opinions, so now it's time for you to ask your questions to Guido, Steve, and Natalya. All right, first one, let's go.
Hi guys, thank you so much for coming out and lending us your time. It was a really good presentation. So we have a TV show called Ghost of Ruin, which is about teenagers going into the metaverse. Once they start dying in the game, they're dying in real life. But we're also working with Gala Games on creating a metaverse game in Unreal Engine that we're trying to create interoperable assets between what's going on in our show, virtual volume sets, virtual volume assets in Unreal Engine 5, and then what we're building in the game. Do you see that as a more common solution for IPs and sort of this integrated ecosystem between the film side of entertainment and the gaming side of entertainment? Thank you.
Wow. I mean, canonical statements, probably yes, right? I mean, I think if you look at what's happening today in terms of content, it's expensive to create content. And the more people can experience this and more variety of media and a more variety of ways, the better it is both for the people experiencing the content and for the creators. So I would imagine so.
Thank you for everyone's presentations. Really incredible morning. I wanted to ask, I really like the asset journey slide from Natalya, and wanted to relate it to how the web kind of settled on JPEG as an interchange format that could be viewed everywhere, but also remixed, turned into memes, these kind of things. And you talked a lot about real-time 3D, format that might be a common substrate of delivery. Memes are often generated without proper content licensing, etc. So relating back to Neal's commentary about ownership and ownership tracking, do you think that a common real-time format that's common everywhere is going to involve a lot of subverting creator intents, like making remixes that are not intended by creators, or do you expect it that the control and ownership systems are likely to play a big hand in preserving creators' intents as their work gets reused? Yeah. And that, to anyone on the panel, but I guess Natalya hasn't had the slide. Yeah.
So Alisa, I just want to call out that we have another presentation in a few minutes on, it's going to touch on this topic, so
this in itself
don't miss the NVIDIA part of it in a few minutes.
This in itself is a super crazy complex topic, but I guess there's a couple things. So one, I don't know. I'm sure all of us will say, but what I would say is this, right? If you look at music and if you look at, some of the needs there, there are, for example, places where you can, grab any free sample and mix it in, right? And that is enabling crazy amount of creativity. And then there's another aspect, which is creators are failing to sustain themselves because there's no way for them to monetize, legitimately and properly monetize, right, their creations, because they just take on a life of its own. So there's two elements that I would note from that, which is one, yes, I do believe that there needs to be some element of free composability access, which will have to come, and Guido touched on it, the openness, right, has to be a key part of it. I can do text in pretty much any way on an image on an iPhone. Sometimes I have to buy a fancy app, but most of the time I don't. But most of these apps are cheap, so it doesn't even have to be fully free. But the other aspect, and it's not about DRM, it's about how do you enable, ultimately, IP clarity to evolve with modifications of content. That's one way that I would anchor that in. And that is a really big need. If we want this creatorverse to live and thrive, then I should be able to create, I don't know, a cool character. And then anybody who builds on that character, frankly, I as a creator want to get a little, dime from that. And that's the right thing to do to create thriving creatorverse. That needs to be solved. I have some opinions on that, but I don't think we're at the answer point yet. I don't know if that answers.
Yeah, this is great, thank you.
And to add, the standard itself, we wanted everybody to open and deal with this asset and it's separate from the ownership. So the way we're seeing it, let's at least lower that barrier that is not you cannot even open it. Then there is another conversation about how you recognize ownership and of the creation.
But it's worth discussing that in the standard conversation because I feel like the embedding should be carried with the representation.
So talking about standards and reusable components, I was wondering, is there any thought in the design to make things more inclusive? For example, how do we make sure that the experience can be had by everyone? For example, when the assets are created, will the standards recommend to create captions? Or will there be some sort of screen reader for things like that? So because I believe we're at that stage where we have this brand new technology coming, and there's a great opportunity to be very inclusive.
This is a super good question, honestly. Couple points, and then maybe you guys also have an opinion, but couple points. One, I think this is where scalability and LOD is a really key part of it, and I'll touch on the captions in a second. But what I mean by that is you need to be able to get it to a variety of form factors that don't require super high-end experience machine. They don't require cloud. They don't require, so that there's accessibility, right? And then the other part, and this is where I'm actually hoping the usefulness of AI will come into play, right? Right now, there's a bunch of research that is happening on conversion from text to final representation for, let's say, image and animation. Guido showed you a whole lot of examples that ultimately were text to a thing that is experienced. Vice versa needs to go as well. So as I'm creating a performance, I would love for that performance to come with, an actual AI-driven captions. So we can automate it. And super short story, right? Just even doing captions for the Advances talk nearly caused me to blow my brains out because of the complexity of it. So if anybody's here doing machine learning, I'm gonna challenge you to go and create that, because that's gonna be necessary to create that accessibility. And we aren't investing enough into that, but it's, again, a part of the Creativeverse has to be serving that.
Yeah, so I was just going to add I agree, that's a really good question. And USD as a standard for describing scenes actually does not put a policy on how you do it. So it's very open-ended. It's really just a mechanism and tool. And I think the next kind of phase of things would be to start talking about policies around how you actually use USD in the same way you just described. So thank you for bringing it up.
Thank you.
That's a great question.
Thank you, everyone, for the questions. We're going to move on to thank you. Thanks, everyone, for the questions, and thank you for staying with us all morning. We're going to move on to our final amazing presenter. So I'm excited, of course, for the Metaverse, for gaming, socializing, and meeting. But the Metaverse is going to be so much more. So I'm pleased to introduce our next speaker, Lebaredian, Vice President, Omniverse and Simulation Technologies at NVIDIA. Rev leads the Omniverse product, engineering, and research teams. Omniverse combines the rendering, physics simulation, and AI pioneered by NVIDIA into a single platform for creating and simulating physically accurate virtual worlds. For those who know me, that's something dear to my heart. And Rev's going to talk about how NVIDIA is contributing to building the foundations for the open metaverse and the opportunity of the metaverse for applications beyond entertainment. And Rev is a really enthusiastic and passionate speaker, so we're in for a treat. Rev?
Thank you for that amazing intro. I hope I live up to that. We've all been hearing a lot about the metaverse and a lot about it today. Generally speaking, most people tend to focus on the aspects of the metaverse that are likely going to be something they personally experience and interact with, the consumer kinds of experiences, entertainment and gaming and whatnot. And those are really important, and we need to build the foundations for that aspect of the metaverse. But if you look at history, look at the past few decades as we built out the internet, you see that the internet has been used for, and the web has been used for entertainment, it's been used for gaming, it's been used for socializing, but we've used it for so much more. It's far greater than just those things. The way I think about the metaverse, everybody has some definition of it, and none of them are wrong, because it's evolving and we'll see what it ends up becoming. But from my perspective, as somebody who's been on the internet for a long time, even before the web existed, I feel like it's kind of like the third generation of the internet. There's the pre-web era, which I got to experience a few years of. Maybe some people in this room, I see some graybeards around there, also experienced it. It was pretty awesome back then. It was much smaller, and it was very open. The whole thing was built on open standards, and there was all this sharing going on, and it was just a bunch of smart people sharing ideas. There were some flame wars, but looking at it compared to what we have today, I mean, it was child's play, when there really wasn't much evil there. But in 1993, when the web was introduced, built on open standards, everything changed. It transformed into the next era. Previous to that, the only way you could really interface with the internet was through text. You opened up a Unix shell, connected over a slow connection, and you could do all this amazing stuff, connect to anybody anywhere in the world who happened to also know how to use that interface. But the web changed everything overnight. Now, essentially anyone that knew how to use a graphical user interface could read text and look at images and click on them, could now participate in this medium. And it invited millions of people. It eventually grew into billions of people that were on the internet. This next era that's forming right now, the metaverse, is essentially an extension. Now we're going from text to 2D to this 3D internet. And it's a really significant one because we as humans have evolved over hundreds of thousands of years, and actually in our evolutionary history much longer than that, to understand the world around us and the other players in this world through many different channels. And what we've had with the internet for communication has been largely abstract, something very separate from how we experience the world around us. So we're bringing this 3D world, everything we understand around us, into the internet or on top of it, so that we can start interfacing with all of the things in there, as well as everybody else, through the normal mediums and channels of communication that we've always known. We can use space, we can position ourselves relative to each other, we can use facial expressions, we can point and gesture and do all of these things and communicate with each other. And this is really, really significant. The idea that this abstract thing that connects all of us everywhere now starts to become like our real world. And the implications of that are far greater than just entertaining us. We already use the internet to work, to build things, to create all of the things around us. And being able to turn that space into something that's like our real world is going to introduce new things we didn't expect. So there's applications to the metaverse that I think are worth exploring now. Now, some of the things we're going to need for the metaverse, just like the web and the internet kind of forced us to create new types of computers, new types of networks, new architectures, the metaverse is going to do the same thing, but it's way more extreme. I don't have to tell people here in the SIGGRAPH community how hard 3D is. It's especially hard doing physically accurate simulations in the 3D world. It's even harder when you need to do it fast, make it real time or super real time. It's super hard to make it multiplayer, make many people experience the same space-time inside these virtual worlds, just like we're doing right now in this room. So we're going to have to do a whole bunch of things. There's a lot of talk about open standards. It's really great to have Steve and Natasha and everyone talking about USD. I've been shouting off the rooftops about it for many years now, and it's great for uses outside of M&E. I'm so happy to see that everybody else is also thinking the same thing. We have to build this together. I mean, it's impossible to imagine the web as it is today existing if in 1993 HTML didn't exist. HTML was very basic. The first version, basically all you could do was combine images and text and do some hyperlinks, but that was enough to cause this Cambrian explosion of internet technologies and applications. If every browser had a different way of interpreting the same data, or everyone had their own way of encoding that data, we would never have been able to create this. We need new types of computers. We need to think about computers very differently. The way we think about computers today, most people think about it as the device that's in front of them, or maybe some computers running in the cloud somewhere backing that. We need to think about it holistically. There are latency considerations that the metaverse is going to impose on us to share this space-time that are just, quite frankly, physical limits. You know, we have to deal with the speed of light if we're going to create immersive, interactive experiences. And so that means that we have to have the right amount of compute in the right place at the right time and combine it all together and think of it all as one system. This is a full stack problem. We need new algorithms to do simulation. They need to be physically accurate. So there's a lot of questions here earlier about whether the metaverse should be based on real world physics and match the rules of the world around us or not. I think already we have many elements of the metaverse. We mentioned all these great games that are metaverse or sort of like proto-metaverse experiences that are here, Fortnite, and there's Roblox, and so on and so forth. But making physically accurate simulations is something that's really, really hard. And so we need to start thinking about that particular problem, because if we can do that, then we have a link back to our real world. And the experiences that humans have evolved to experience start to translate into the metaverse as well. It becomes more natural for us to interact with it there. We also gain some superpowers, which I'll talk about in a little bit, if you can do that particular thing. The other thing that's happened in the last 10 years that's really changed everything is the emergence of AI. I mean, the idea that we can now write programs that write programs. We have algorithms that are being created by software that we've written that previously, and to this day, humans can't create themselves. We've failed at writing a robust algorithm that could tell the difference between a cat and a dog for decades and decades, until we discovered this combination of computing and data and some pretty old ideas that came from the 50s together to create this modern AI. And the ramifications of that are huge. It means that we have the potential to create algorithms that can help us in constructing the metaverse. But also, the metaverse is an essential element for constructing the AIs. In order for us to create these algorithms, to create the intelligence, to create these thinking things that can go do their specialized skills, we have to feed them with data, which is sort of another way of saying we have to give them experience. We have to give them living experience. You need to tell this perception AI, show it many, many examples of how things look in the world before it can do its thing. And the only way we're really going to be able to construct that data, the only way we're going to be able to create the amount of lived experience, the millions and millions of hours that they're going to need to experience before we unleash them into the world in the form of robots, is by synthesizing that data. And we do that in virtual worlds. And we're going to do that using the decades and decades of innovations that have been created here at SIGGRAPH, and for all the participating members, simulating virtual worlds and generating all this data. We need these AIs to help us in both ingesting the real world into the virtual one. We need to find methods of capturing everything around us and representing it faithfully inside the virtual world. And we also need assistance to come help us create in here, because quite frankly, if the metaverse is, if you think of it as sort of the next web, the 3D web, one of the key ingredients for the 2D web was the ability to crowdsource the creation of everything in there. Anybody could open up a text editor in the early days and edit some HTML and create content. But that's not true today in the world of 3D. Creating 3D content is really, really hard. It's something that only a small number of people in the world really know how to do well. So we need these AIs to come assist us so we can democratize the creation of this. Otherwise, it's going to be dead on arrival. I won't belabor the whole USD thing, but I think it can't be overstated how important it is to have a common description and have kind of one thing that we're going to build on. I don't think it made sense for the web to have multiple HTML, hypertext markup languages. HTML 1.0 in the early days was extremely simplistic. It took about 2 decades to get to HTML5. And the extensions to it that were proposed and the proprietary additions that people did along the way, we learned a lot from those things, but we converged on something that really works, and it's great. And it continues to evolve. The same, I believe, will be true for USD. The form it's in today is actually way more sophisticated than HTML was in 1993. And I think it's a good foundation for us to build on top of. One of the misconceptions I'd like to get rid of is that HTML is just a file format. There's this false equivalency that seems to be happening whenever you talk about USD, comparing it to all the other file formats around there. A file format is part of it, but it's far more than that. It has a composition engine. You heard a lot about composability from Natasha and from Steve. This is a key feature that's really, really hard to do, and nothing else has. So anything else that we decide we want to try to make work for the metaverse, we're going to have to add this stuff. And quite frankly, it's going to take a long time to do that. So it's better just to start from the great work Pixar has already done instead of reinventing the wheel here. And anything that's imperfect, just go fix it. It allows us to extend USD. It's extremely general. You can describe any kind of data. It doesn't even have to be 3D data. You can add your own schemas. We still need to solve a lot of things around versioning schemas and all of that kind of stuff. But quite frankly, no other 3D file format has that kind of extensibility and flexibility. There's mechanisms within USD to interface with existing sources of data. There's asset resolvers, ways of dealing with your own storage systems that abstract away all of the file stuff. That is very unique to USD and extremely powerful, allowing it to integrate in with your existing legacy data sets and pipelines. And Hydra has been touched upon a little bit in the previous talks. I think this is something that's not well understood and also a very profound addition to what we're doing over here that I think we're about to start seeing the implications of. Hydra is not really USD, but it's sort of a companion API that comes with it. It's an abstraction that allows you to combine different tools that have their own scene graphs and scene descriptions with different renderers. The terminology used within Hydra is delegates. So you have scene delegates that abstract away a particular way of describing a scene. And there's render delegates, which are renderers. Hydra lets you connect these to any scene delegate to any render delegate. The scene delegate that comes with USD is for the USD scene, but anyone is welcome to write a scene delegate that's unique to their particular data sets and their tools and their engine and their runtime system. And once you've done that, you essentially can connect it to any renderer that's compatible with this. So this SIGGRAPH, we've seen a bunch of really great announcements for new render delegates. Autodesk announced one for, I think it's called Aurora. It's a real-time path or interactive path tracing system that's going to be open sourced. Anybody who uses Hydra can just plug in this renderer. Same with DreamWorks, just announced that they're open sourcing Moonray, their production path tracing, physically correct rendering system. The whole community benefits through this kind of interoperability, and so we shouldn't forget about Hydra. I mentioned we need a new computing platform. The metaverse is going to be really hard to build in the way that we're imagining it. The computers that we have today are really insufficient. The way we connect them together, the way they talk to each other, are nowhere near where it needs to be in order for us to have those kinds of experiences. Fortunately, there are many that are working on it. We're working on that, on pieces of it, but this is a problem that's much larger than any one company, than any one enterprise. Just like building the internet and getting it to where it is today was much bigger than any one company, this is even harder. The amount of computation necessary to do high fidelity, realistic computer graphics and simulation is essentially limitless. We can always do more to match the world more closely. It's orders of magnitude greater than any of the other types of applications that we run today in our data centers and in the cloud. We also have hard requirements for latency and interactivity, which, and the ability to synchronize time between all of the different computers that are contributing to our experiences that are very unique to this kind of application. We need to build new types of networks where we can synchronize time. We need devices that not only have enough computing power, but just the right amount of computing power and the ability to synchronize between themselves and the other elements. What we're going to see evolving is tiers of computers. There are data centers where the majority or the bulk of the compute that needs to happen for a shared virtual experience will live. But we'll have to have computers at the edge, much closer to the users, for some elements of that compute that need to be lower latency. And finally, there's going to be the devices we actually wear and carry around with us. Those are extremely constrained, and we always want to minimize the amount of compute there because there's weight and battery and heat considerations. So look to what's happening there, and I think a lot of people have underestimated what the problem here is, focusing primarily on the more abstract things in the software layers of the stack. This problem is a full stack problem. We need to solve it all the way through. The metaverse, largely when we talk about it, people usually think of it as these fantastical places that are imagined and anything, you can create anything, and that is awesome. And that's essentially what we do with video games. So I'm a gamer, I love it, I love going into fantastical places. I did visual effects back in the day before I joined NVIDIA. All those things are really great, but amazing things happen when you can reproduce the world we live in now inside the metaverse, in the virtual world. Once you can do that, if you can make a replica that's close enough to the thing that you care about in the real world, you have the opportunity to link them together. So the things that we need to create the virtual world, I think many people know. There's some basic ingredients. We need to be able to simulate how things look. That's essentially rendering, which is a simulation of how light interacts with matter. We need physics inside this world. It's the behavior of all of the objects and things inside it. And we need agents in these worlds. We've advanced enough in all of these areas, and we have enough compute to be able to do a significant amount of that to make good replicas of the real world and actually do it in real time and super real time. It turns out that most things that we build in the real world these days, almost everything you see around you, at some point in time in its design phase existed in the virtual world. That the chairs you're sitting on, the building that we're in, some architect or some designer used a CAD program of some sort to create this 3D representation of it. Unfortunately, that data usually ends up getting locked up in these little islands. They can't be composed together. If any of you have ever had the misfortune of doing a renovation or building a house, you know that your architects, they'll design some stuff and show you some renderings and things look awesome. But the moment construction starts, everything diverges. The thing that you're building no longer is like the thing that your architect gave you. And unfortunately, we don't have systems in place yet to bring those changes from the real world back into the original design. But if we can do that, if we can construct systems that allow us to keep the real world thing and the virtual world thing linked together, and we can capture in real time the state of that world. Say we have something like a factory. These factories are very complex these days, particularly in automotive. Thousands of people design such a thing. There's architects and people doing the HVAC and the robotics and conveyor belts and speeds and feeds and all that. They design all of that. if they've designed it and simulated it, they can be certain that when they build it, it's going to work. But once it's built, if they have a working simulation, they can feed back information about what's happening inside that factory back into the simulation. We can sense where the humans are, where the robots are, what the speeds and feeds are working like. And so that fundamental thing, that link between the real and the virtual, gives us a few superpowers. The first one that's kind of trivial once you have this is teleportation. If you have your factory completely mirrored inside the virtual world, and you have a simulator, an engine of some sort, that will let you travel to that the virtual version of it, then essentially you can teleport to the factory. If the physics of everything matches, if everything looks the same inside the virtual world, just like it does in the real world, then there's really no fundamental difference between actually being there in the physical world or the virtual version. But it gets a little bit better if you can store that state. You can store that state over time. There's no reason to just throw it away. If you can buffer it up for some period of time, you essentially get the ability to time travel into the past. So not only can you teleport to any position in your factory, you can rewind to some point in time that you've already stored. So you get this time travel ability. You can go debug issues that happen in your factory, or just check it out because you're curious. Where it gets really, really crazy is if you have a simulator that understands the rules of the world well enough, at least for your thing, that you can predict some point in the future. If you can predict what's going to happen in the next few seconds, in the next few minutes, or even the next few days, then effectively this digital twin gives you the ability to time travel into the future. You can go see problems before it happens. Now, the key here is that you have to do it fast enough. If the amount of time it takes you to go do that simulation is greater than the actual time for it to happen, then it's sort of useless. You need it to be really, really fast so that you can act upon it before it actually happens. And if you can make it really, really fast, then you get this awesome fourth superpower, which is the ability to explore many possible futures. You can take your factory and take the parameters of your factory and wiggle them around, try different configurations of your workspaces and the robot speeds and energy usage and all of that. Just and try them all out and go find the one you like the most, the best possible future given your constraints, and choose that and go act upon it. When we think about the metaverse, usually we think about it at our sort of human scale, hanging out in rooms or in spaces that are normal to us. But there's no reason to limit ourselves that way. We can build virtual representations of the world at any particular scale, and there's many good reasons to do that, especially if our simulators can be accurate enough to predict the future at those scales. We could build digital twins at the molecular scale so that we can help with drug discovery, vaccines and stuff, really important these days. Of course, I just mentioned factories, but we can start getting bigger and bigger. We can simulate whole cities, optimize for traffic patterns, for livability, minimize pollution, do all of these sorts of things with those digital twins if we can keep them synced. And of course, we need to do this at the planetary scale because it's the only way we're really going to solve this climate, the climate crisis we're going through right now. If we are to solve it, it's quite clear that whatever we need to do to solve it is going to be very costly and it's going to take time. We probably don't get many opportunities to try to go solve it, and convincing the world to invest trillions of dollars into a solution that you're not certain of is unlikely to happen. So the only way we're really going to solve these big problems is by first creating a simulator that lets us test out all the possible solutions. And we have to have enough confidence in these simulators that they are actually predictive of what's going to happen so that we can make actions or make decisions and act upon these things with confidence. I'm going to end off here with a little video showing some of the industrial AI use cases that we've shown before as NVIDIA. Robotics is essentially the ultimate expression of artificial intelligence, and virtual worlds are key to constructing these robots because we need a place for them to be born, for them to have experiences, and for us to make sure that they're good robots before we inflict them onto people inside the real world. So here's some examples of some robots that we have in simulation and in reality. And what's amazing is that we were able to train these robots completely in simulation and in one shot, just bring their brains trained inside virtual reality over into the real world, into the real robot, and have them behave well, behave like good robots. You can see some here side by side. It's critical that the physics of these worlds are as accurate as possible and matching the real world. Here's an example of one of my favorite robots, the Animal. It was trained completely in simulation to walk around on these wheels, and it can do all those cool tricks like stand up because it had millions and millions of hours of experience in the virtual world in super real time before we transferred its brain into the real robot in the real world. All right. All right, so in summary, if you could take away just one of the things that I spoke here, I spoke about a lot of big ideas, some crazy ones. First, that the metaverse is going to be more than just about social stuff and entertainment. Those things are very important. That's going to be huge. But we should also be thinking about the more expansive metaverse and how it's going to apply to every aspect of our lives. And that includes how we work, how we build, how we create things in the real world. Without open 3D standards, there is no metaverse. We just cannot build something as great. We can't even meet the grand challenge of the metaverse without first having a foundation that allows us to all communicate with each other. And that means standards. We need to build these standards together because no one of us can build it alone. We're going to need new types of computers and a new computing architecture. This isn't just a software problem. We need to create new types of hardware and computing architectures that span the globe. We need to think about computers as something more than just the device that's in front of us. It's the collection of all of the processing units all over the world and how they're working together in concert with the software that's going to deliver this experience. And it's a really, really, really hard problem. It's going to take us a while to solve it all, but I think we made some good strides recently. And let's just keep going. We need real-time, accurate and high-fidelity simulations for the metaverse. I know there's a debate of whether the metaverse is just fine being cartoony, and I think cartoony is fine. You know, we go watch cartoons all the time. I love cartoons, but I'm not sure I want to spend my whole life in one. So I'd like a metaverse that matches the richness and complexity and is similar enough to the real world for me to want to be in there for many hours. And ultimately, I want to integrate the metaverse with the real world. We're going to mix the two things together and hop from one to the other and make them indistinguishable. So we absolutely need those types of algorithms. Artificial intelligence. AIs are going to be born and raised inside the metaverse. I would even argue that advanced AI, is not going to be possible unless we build the metaverse. This is kind of a necessary prerequisite for us to to create these AIs because they're not going to gain enough experience and learn enough from the world outside here with us. The amount of time it takes for them to have an experience and the cost of that is just too high. So we need to do it in the virtual world. And also, the metaverse can't exist without AI. I just don't see any way, if we continue down this trajectory of 3D content creation, that we're going to have enough content in the metaverse to make it compelling enough, to make it as powerful force in our lives as the web has become. So we need to find ways of harnessing this AI to assist everyone to become a creator. All right, with that, I'll open up for some questions.
Thank you so much, Rev. That was super inspiring and very forward-looking. I appreciate you opening up our eyes to the breadth of use cases and the potential scale of the metaverse. I have some questions, but I see some people already lined up, so would you like to go first?
Hello, me again. Thank you so much for the incredible work you guys are doing in Omniverse. I had a question on kind of the future of it in the sense of, I know that your cars are giving you kind of real-time data based on, cities like New York City and kind of showcasing the buildings. And then you're able to use AI sort of procedural generation to kind of create 3D, basic assets that are getting higher and higher in fidelity. When will that be able to be used on the gaming side and on the film side for entertainment, almost like the digital twin of our world is able to be explored for gamers and for entertainment? Thanks.
Well, you mentioned Omniverse, which is the 3D platform, simulation platform that we're building. We built Omniverse on top of USD from the start to be USD native because we were really clear-eyed about the fact that there's no way that we are going to be able to create all of the tools necessary to construct everything inside the metaverse and in these virtual worlds. It's even more extreme when you're talking about building physically correct virtual worlds. If you think about it in its limit, if we are able to create a simulator that matches the real world exactly, then the tools that you're going to need to build stuff in it are going to be exactly like the tools that we have for the real world. And in the real world, when we build something like this building, we use many, many different tools for that. So the first order of business is just getting all of the stuff that is being built inside these different tools to come together. And for that, you need to have a common standard to represent them in the same space so you can compose them. Once it's there, you can, as long as you have a high fidelity, the most accurate and the highest fidelity representation of that data, it's much easier to target it to different platforms and targets, specific runtimes, specific simulators for specific use cases, as long as it's just a reduction of the fidelity. Going the other direction is always really hard. So if you have your city in its highest form of representation, with petabytes and petabytes of data, obviously you can't use that. You don't need to use that much data for your particular video game, but you should be able to reduce that down. I mean, today, when you upload your high-quality videos up to YouTube, it automatically gets transcoded to many different versions of it for streaming at different resolutions. We need the same thing for 3D. We need to be able to define the highest quality thing that's kind of the reference source of truth of your virtual world and derive from that all of the different targets.
Yeah, I'm so excited about it because I hope for a one day in which when we're playing games in the metaverse, it's like, okay, what level do you want to play? And it's like, oh, just what neighborhood in Brooklyn do you want to play in? And that is just really exciting the ways you guys are building. So thank you so much.
Yeah, so we're trying to build the kind of plumbing to allow for that to happen. And that we're at the very bottom layer of that foundation. That's why USD is so critical for the way we're thinking about it. And I think everybody else here is starting to think about it in the same way too.
Great. Thank you, Rev. Does anyone have one more quick question? Go ahead, please.
So when you say an accurate physics representation, what do you mean? Because the real world is, you know, what are we talking to, like Planck level detail? I mean, like are you talking
infinite
rigid
compute.
body physics?
Yeah, I mean,
or-
that's what we would want if we had an infinite amount of compute. Unfortunately, that's not the case. So we have to settle for approximations. There's some good news. Those same AI techniques that I was talking about earlier are being applied to essentially accelerate simulations to make them more accurate and match the real world. We're always going to have to settle for some difference between our simulation and the real world. We're going to need specialized simulators for different problems. We already have that in this case. So it's just depending on what you need to do, what that bar is for accuracy. Sure. But what we should be striving for is the maximum always when we're constructing our data, when we're constructing virtual worlds, because we want that data to be durable and usable across many different simulators.
Right, but when people build content today, all they're building are facades, right? No one actually, like if you create a pencil, no one's creating a pencil, they're creating the outer surface of a pencil.
Right.
Right, no one's worrying about the interior physical
That's
properties.
not totally true. Probably that pencil designer somewhere used a CAD tool that was using solid modeling, and there are insides. They exist somewhere. They just didn't end up translating into something that the marketing team could use. But the marketing team got their hands on that pencil model. It was just a shell.
Maybe, but like if you're modeling New York City, you're not considering where all the rebar is. You know, you're not thinking about like how each sidewalk plate actually got, you know, physically laid. Like,
well, I agree with
all
you
that
that
stuff is
somebody who's
missing.
trying to create New York City for a video game or a movie today is not. But the architect who created that building, if it's a recent one, did. The rebar designs for it existed somewhere, and unfortunately, it probably, the designs he had are dated, and the real implementation of that design, the construction ended up not matching exactly. But if we can solve that problem, make it easy for, to keep the digital twin consistent with the real world thing during construction and after, then you will have all that information.
Yeah, this is a big topic in the construction and AEC and digital twin and geospatial worlds. It's actually something we're going to cover a bit this afternoon that Nadine will talk about. Given the time, I think we're ready to wrap up. Let's thank Rev once again. And then thank you, Rev. And before we head out, just a reminder, we're going to pick back up at 2:15 this afternoon. Morgan McGuire, Chief Scientist at Roblox, is going to kick things off. And then let's just do one more round of thanks for all the presenters this morning.